Thanks for joining the great event. Uh, let's start. We have our first speaker, Dinesh Kumar. He's going to talk about uh, embrace data mesh architecture on Microsoft Azure data platform. Dinesh, all yours.
Thank you, Rajesh. Thanks for your introduction. I welcome you all for this event, guys. So this is going to be the first session in this AZConf track 7. Yeah, and I'm Dinesh Kumar. I have 9+ years of journey around data and cloud. I work for different products which are mostly of B2B based, and the business intelligence products and the analytics product, which was around the SaaS. I was always passionate about Microsoft Azure, and recently I'm more passionate towards low code and no code topology as well. And definitely, I believe holistic growth happens via knowledge sharing with tech communities and interesting people like you. So let's start with the today's talk. It's going to be how we can embrace data mesh, not making the data to be messed around. So this is going to be my agenda. First, let me tell what is the idea behind data mesh. Why such a concept has evolved, and why such a thought process has arisen, right? And then let's talk about what is the other end of data mesh, right? When it is going to be microservices in the application development world, monolithic was present at the other end, right? Similarly, let us discuss this same paradigm in data perspective. And proceeding that, let me share my knowledge at Kissflow, where such a kind of topology, data mesh kind of topology, helped us to turn the data into insights. And then the major idea of data mesh, that is thinking data as a product, right? Let us see how it can be architected logically, and then how we can embrace data mesh via the services provided by Azure cloud provider, right? So let me start with the idea of data mesh, right? um, every time some concepts get into the picture, right? Before a decade, big data was a very booming word, right? Everybody will be talking about big data. Oh, what is the big data? It is going to be the future. There was a lot of myth revolving around big data, right? But even at that point of time, I was thinking that why such a demand has arisen all of together, right? And similarly, the same thing today, many of us are talking about data mesh, and the same question I get into picture. Why that idea of data mesh has arisen? When we see before, maybe before a decade, decisions and works revolved around people, and softwares were just helping them, right? Let us take a simple example of bank. Before 10 years, when we are visiting a bank, there will be many people sitting around. For example, as a customer, I want to submit a loan application. Let us consider that is the scenario, right? So what I need to do, I'll be going to the bank and approaching a person who is sitting at the front desk. He'll be targeting me to go to the right person, where he might be sitting somewhere else, and he'll be asking me the details. Okay, what are you doing? What is your income? Do you have an account in this bank or some other bank? What is do you have any other loan? And all the details that he'll be collecting it. He'll be noting it down. He'll be uploading it into his software, and he'll be asking us to come a couple of days later, right? Uh, what will be happening in the bank? In the bank, the banker would have collected all the data and uploaded into the software, and based on the details present in that software, it will be going to some other person, another person, right? and that person will be checking my credibility, whether this person's information is correct, whether this person is authenticated and valid to receive a loan, and all those things like that. Then it comes to the bank approval manager, then it comes to the bank manager, then it comes to some other person, and finally they'll be telling that okay, your loan is approved. This is what that is what the process will be going on, where the software and the humans will be integrating together, right? Where most of the decisions will be taken by the human, right? But what happens now? Softwares drive the business, right? The employees just use the data and they are scaling the business altogether. The same scenario, just imagine in current scenario, already my details, my quality of my economic quality, everything will be uh, noted somewhere, and I was given a score, something called as credit score, right? Out of 1,600, 700, or something, right? So if I just log into a mobile and I just click that I need a loan of 5 lakhs or something, all the operations from checking my valid myself as a valid person, myself my income is valid, my whether my credit score is valid, everything happens behind. And finally the app itself will be telling me that you are eligible for the loan. 2 lakhs you are eligible in 10 minutes, but in case if you want 10 lakhs, we can our customer representative would call you back in few minutes, right? 2 lakhs of loans just happens within a couple of seconds, because everything, all the data that happens around the bank as a customer lies behind the software and stores behind some database. And when some other new request gets into the picture, that is requesting for a loan, right? Requesting for a loan is not an actual need. The actual need of a bank for as a customer is, I need to transact, I'll be depositing the amount, I'll be withdrawing the amount. That is the need. Even though a new need like requesting for a loan comes in, even that happens within the minutes, all together behind this behind the topology. But see, how it makes how it visuals this picture and this picture, right? This picture, when you see here, it is totally looking like a mess. It is looking like a spaghetti, right? uh, Many softwares are integrate are communicating with many other softwares, and those softwares of course they communicate with some other database, and those databases might be in on-premise, might be in one cloud, might be in other cloud, and might be having different schemas, might be based on different domains, right? There is a lot of complex thing that happens behind. So what happens here? Actually, the primary purpose gets solved. The primary purpose is, as a customer, the bank is able to provide me loan, that is fine. But what about the other insights, right? Because the other insights I mean here is, what else the bank can promote to me to increase the business of bank, right? Well, that is the question. But again, let me ask this: the primary purpose is to provide the loan to the customer, that has been provided, fine. Then why the extra insights are required, right? That is a big question, right? But it happens in this current world because expectations has increased for the users to a wide extent. If you take giant companies, right? Netflix, Uber, those people, they made the front end customer experiences as smooth as possible. Even an elderly person can book a ticket. Even a small kid can watch a movie or watch a show which she likes, right? A 3-year-old kid, right? Even a person who doesn't know English much can use such a software. So they made that rich front end customer experiences so rich, right? And customers are demanding more from all the apps that we are using. Either it could be a very new app, either it could be a developer app, right? A developer who is using, let's say, even Microsoft Azure or Amazon Web Services, even a developer is expecting that Azure or AWS or GCP to be so developer friendly, so that the developer can complete his work as soon as possible, right? And that's where the product analytics comes into picture. Okay, that is again a very big chapter. I'll walk through in in few slides later. But what I'm coming to say is, every company, every software has been pushed to get digitally involved. And what happens due to that, when they are getting digitally involved, they start to introduce many new softwares into the company. Okay, for onboarding a new software, for chat a new software, for video calling a new software, for recording the analytics behaviors a new software, and for the CRM a new software, for the marketing a new software, for the product team to understand the user engagement a new software. Like that, every company has started to build itself with so many software interfaces, right? But what happens here? Marketing team, sales team, product team, customer success team, yeah, different teams are there, but each team produces data which are decoupled from other teams. Their team can use their data alone very smoothly. If each team has to use the other team's data, then what happens? Something has to be brought, a data lake, single source of truth, which are all exist even in current scenario itself, where all the data should be pulled into it, and the ETL happens over there. And again, a clean data gets moved into some other picture, some other database or data warehouse. From that, the insights start to appear. But the company doesn't have time, right? The Netflix or Uber, just think how much data they are producing, but they're able to produce the insights in a second, right? Last month, same date, I might have visited Chennai for some other work. This month, at the same date, it is showing me that, would you like to, you have 10% offer, would you like to book a Uber cab for us, like. So everything revolves around software, right? Less people and more software. That's what the complex situation is getting around us. Okay, now let's talk a little bit about the other side, technical side. In the application development, two types of architectures are there: monolith architecture and microservice architecture, right? Monolith architecture is very simple. Everything, all the changes will be bundled, all the development will be bundled into one single one single application or DLL, and that will be deployed, right? Before 10 years, if you want to upgrade our Windows operating system in our machine, it need to be all we had is, we need to go somewhere, we need to buy the latest Windows operating system OS, that we need to insert that CD into our computer, then the Windows gets upgraded. But what happens now? Every day we are constantly getting that, you have some Windows updates, would you like to update, would you like to update, like, because the Windows operating system, that much huge software itself, been split into microservices, and we are able to, as a user, we are able to be in the updated software every time, right? So that's where this microservices paradigm has been, sorry, monolithic paradigm has been broken down into microservices, where a single package will be there, that is what it is being serving for the customers. Whereas in a microservice architecture, the major portions or the major domains will be totally separated. The UI service, stock service, order service, everything will be separated, so that if anything goes down in one service, that doesn't affect other. And even since the broken piece is easily identifiable, it can be easily fixed, and we can keep the wheel running as soon as possible, right? So when it comes to data perspective, again, the same thing happening. I'm not telling that this is exactly monolith architecture, but The classic data integration is also a kind of monolith architecture, because we'll be having data getting generated from different sources, and all those data will be pulled into either a data lake or a data warehouse, where this data lake or data warehouse acts as a staging area. From that staging area, the ETL happens. Once that ETL done, again a cleaned data will be stored into a data warehouse or into a database, which they call it as data mart. And once that clean data is available, different people will be consuming it. Just consider this person is a data scientist. He might code, he might write some code, Python code in his Jupyter notebook to extract the data, to do some operations and get some insights. Similarly, there could be some other person like a data analyst. He might be pulling the data via SQL query, and he might do something. Similarly, there could be some business intelligence specialist. He'll be connecting the data warehouse with his Power BI tool and playing around, right? But what happens here? All the data, this could be sales data, this could be customer success data, this could be products user engagement data. All the data gets pulled into one data warehouse. Again, if a persona from here want to take an insight, he need to fetch the data from here only, right? That's what the current architecture relies in. Yes, it is working in some cases, like in this monolith architecture. Still many successful applications are running as monolith architecture. This classic data integration also works in many perspectives, but what happens? It doesn't work in all the perspective. So as a technology leaders, as a data architects, they need to think over some other alternate architectures as well, or some other topologies as well, or some other frameworks as well. And that's where data mesh comes into picture, right? And also, every company today, they are ready to invest, and they're very open to invest a lot over data, right? Even they are many of them are investing as well. We can go for the cloud, we can go select the latest cloud service. And like the companies are ready to decide, right? They're ready to burn the money. But upon certain surveys, what what we are able to see is the return on investment is not so big. The ROI is the ROI is expected while investing is not able to be produced after some time, right? Because there are few reasons around this. I know some of you would know about Zamat Dahani. She was the one who introduced this the whole concept of data mesh, and she has presented four symptoms of failure for not able to take the ROI, right? Fail to bootstrap, fail to scale resources, fail to scale consumers, and fail to materialize. So here, fail to these three reasons are something related to each other only, because you do something, right? In a monolith architecture, you do something, but at some point of time, you are not able to scale it up, right? Let me give you an example. Let us consider that this is a source of data. Some CRM tool is generating some data. Your some users are getting signed up for a trial, and the trial user is being converted into customer, and all those data are present in CRM tool. Okay, let's imagine like that. It could be Salesforce, or it could be Zoho CRM, whatever it may be. And the data is getting pushed into data warehouse. After a couple of months, you might add a couple of additional fields. Let's consider that so far it has been only country field is present, and you might need to introduce a state field and city field as well. Okay. Similarly, in US they call it as county, right? After USA country, then it comes state, then it comes county, then it comes city in US. Suddenly, your CEO asks you the question of how much deals are we generating in this particular county. Okay. Then in CRM, you need to introduce the field called county. it works fine within the CRM tool. It works perfectly fine, not a problem. But what happens into a data warehouse? You need to change the schema, right? I hope many of you know how big it is changing a schema of a table, right? Because you need to be as a data warehouse person, the IT person. Let's consider that IT person might be very serious that okay, schema change is not an easy thing. I need to cross check in many other places. Just hold on a second. I need a 1 week of time or something like that. Or he might not even accept it. But that change, introducing a conti field, the importance of that, that the CRM lead knows the importance, but we may not expect that the IT person to know that same importance, right? So that there appears the domain gap. The IT person cares about his data warehouse, whereas the CRM lead, the CRM, the sales team lead cares about his data and insights. Only if he is able to introduce that conti field into the data warehouse, he can do the analysis. Either he himself or some other analyst or some other person can do the analysis and get some insights. See, in this particular state, in Texas state, this particular county has produced more customers. 10 customers have signed up for trial. Out of that, 2 persons have been converted as customers. Let us invest more Google AdWords to target that particular customer. Like that, the decision makers can decide, right? But those importance we might not expect the IT person to fully understand. That's the meaning. He will understand the importance, but he might not understand the domain's importance. That's what the problem comes in. That's what it means, like fail to scale resources, right? And fail to scale consumers is nothing but consumer here is nothing but data consumers. There might be a person who is in need of JDBC library all of a sudden. So far, it was not present, right? And that IT person, he need to add it to his queue, and he need to do that, right? Whatever the failure reason marked here, everything just mark it around the domain. Simply say the domain person knows the complete importance of the data changes or the importance of insights. The IT person doesn't fully understand the importance of the data change or the data insight, right? So you might even talk that such a kind of ecosystem is already there, right? We do have IoT edge, we do have edge analytics, and it is not always like a single big puzzle. As you could see, the analytics and data science here, some are done over relational database, non-relational database, data lake, data warehouse, AI, ML, streaming analytics, everything. In a technical perspective or in a top perspective, everything would be looking like a tied together. But in a real perspective, it would be separated. The edge analytics would be running on the edge of the software, right? And some other analytics would be running on the cloud software providers like Azure or something. Similarly, some could be running on the on-premise, and some could be running on single cloud, and some could be running on other cloud. Everything is fine. This is present already. I understand you have this question, but um, still, what I'm trying to tell, data mesh is a new concept or something, right? That is the question. I hope you would have received it. So let's see now, what is data mesh. Okay, so data mesh is not a technology, okay, like a data lake or data lakehouse or something else. Data mesh is not an architecture pattern. It is just a practice. Okay. I hope most of you know about practicing agile, right? Practicing agile doesn't confine into something called as a service-based company or product-based company, or doesn't it confine into healthcare domain, healthcare industry, or supply chain domain, right? Practicing agile in the development, in the development of software is a common practice, right? Similarly, data mesh is altogether a new practice which is not confined to a specific domain or a specific technology or a specific company kind of thing. Okay, this is just a practice. The practice is completely based and has its boundary around the domain. Okay, even the word domain might be sounding a little bit different. uh, you can mark that word domain as, consider it as your own company. Let me consider that you are from a product company. Then sales is a domain, customer success is a domain, product is a domain, and marketing is a domain, stakeholders is a domain. Like that, you just mark it in such a way. Okay, the idea is that data that is generated in a domain, the ownership of the data also relates with the domain. That is what data mesh is all about. Okay, the approach is completely democratized. Okay, earlier it was centralized approach. All the data will be pushed into one place. ETL has been done, and insights have been derived, analysis happens alone. Just consider the opposite, decentralized architecture. Okay, the data will be generated in so and so places, and it will be mostly residing in those specific places only. Everything, all the needs and all the requirements get satisfied within that domain itself. Okay, that's what the practice of data mesh is all about. And the another thing is, when it confines within a domain, the technology choices also becomes independent here. Okay, there might be a Python developer over here in a specific domain or in a specific team. To mean it simple, that particular Python person can use some pandas library and get some insights. The other side, there might be a C sharp guy who is familiar with Azure. He might use some services in Azure, like data lake or streaming analytics or data lake analytics. He might produce some insights, right? Like that, the technology choices also gets independent. But what happens? The choices should be compliant with respect to the company. Okay, just in case, if the company decides, do not deviate out of the Microsoft boundary, then this particular domain where I was telling that he might be a Python developer and he chooses pandas library, then he need to choose that, okay, I should not choose Python, whereas I can choose some other language like F sharp or C sharp itself to do the analysis and produce some insights. Okay, like that, the choice of technology gets independent domain basis, but it should be compliant with respect to the governance of the whole company. Okay, and another major thing is the organization's structure, size, culture, dynamics also gets into picture. If the company's idea itself something like a top down approach kind of thing, then then articulating data mesh itself is a little bit of difficult task. Okay, it is in my point of view. uh, if the whereas the company makes the teams to play independent. For example, HP is a kind of company where it segregates and it segregates the ownership into small divisions where they take the decisions faster, and they are responsible for the revenue, resources, everything. They are responsible for that, right? It is not that everything comes from the top down approach. The decisions, if the company's organization structure remains in a way that the decision making is being confined into their own team, then implementing data mesh kind of practice is a little bit easier. Okay, it's not that you have an expert in data mesh architecture and you have a domain expert. Just with these two things, if you want to implement this practice into a company, it is not going to be easy. The organization structure and dynamics also plays an important role. That's what I mean here. Right. So what the ideology comes into picture when we are talking about this fail to scale resources, fail to scale consumers, and all those things. What is the crux lies behind? Today, since we have cloud, and which is leveraged to scale as big as possible, and which can be leveraged to scale by itself via auto scaling kind of capabilities, always we started to think in a very big picture. Okay, but just think on the other side. If you design for scarcity, then the scalable thing becomes automatically, right? If you design for a small thing, and the software is already allowing itself to scale as big as possible, even a small thing can fit into a big thing, big big space, right? But the problem is we always think about the bigger space. What would be the data size 5 years later? What would be the data size 10 years later? And we sometimes forget what is the data size it's going to be present 2 months later, after the application is getting productionized, right? We forget that scarcity factor itself. But we need to think about the scarcity factor also, because workloads, whatever the workloads we give, it is going to consume resources, and all those resources again comes into physical resources somewhere. It is the server is not present in our picture like 10 years back or 15 years back, but somewhere in some region it is again a physical resource, which is again prone to fail, which is again has all those kind of risks which we were having earlier, right? So what we think is, if we can make our workloads use fewer resources as few as possible, obviously we are going to spend the lesser amount. Okay, when we spend very lesser, then the question of ROI doesn't pop up like a very big thing. Fine. I'm not talking about having a mindset of scarcity, or like a Kanjo's kind of mindset. I'm just talking about design for scarcity. That's it. Have that in your picture. Then the scalable thing also should be achievable automatically. Fine. So now let's come into the picture data mesh. What it is about, and the four main principle which was derived by Zamak. The four principles are nothing but domain drive, where the data ownership is being taken care by the domain persons itself. Fine, that is one thing. The second principle is think the data itself as a product. Okay, so for what we have an idea, something WhatsApp is a product, and the data we that is getting stored into WhatsApp is present within the product, right? But the ideology behind data mesh is, you need to think the data itself as a product, maybe kind of like a sub product. Fine, the mindset, it is not something that data itself need to be thought as a product. Just you need to think that it as a a product mindset. Fine. Why we are telling a product, the word product? Because a product will be independent. Fine, one thing. Second, a very good product will be self-serving. If you, even if a 10 months kid, right, if we just open up the YouTube and give to the 10 months kid, that kid will start to scroll. We didn't thought to do the tap with this index finger, right? But the kid will start to scroll, and it will, that kid will press a video, right? After some time, the kid itself knows how to go to back screen, and it again scrolls in, it again presses some other video, right? uh, that's the essence of product. A product is always self-serve. That's what I mean about. Similarly, the data architecture should be converted something like a self-serving kind of thing, so that anyone can access securely, do the analysis and get some insights, and convert that insights into actions, and that actions gets converted into the business growth, and business growth gets converted into income generation, right? And that's where the ROI comes in. ROI is not so simple. It is a very long process, and later only that ROI comes into picture, right? And next thing is federated computational governance. Simply say governance. As I told earlier, while choosing a technology, even though the domain is independent of itself, it should be adhered into the governance of the company, which technology stack it can choose, right? That is one thing. And while sharing a data, that sharing has to be designed based on the governance of that company's design. Let's consider that the company is built around Microsoft Azure and Active Directory. Fine. Then the data sharing should be happening behind the Active Directory kind of governance only, right? It is not that download a CSV and share that CSV via mail to some other person. It is not a federated principle. If it is a very crucial kind of project like healthcare or something else, then you'll be screwed, right? So even though the domain is independent, while sharing the data within the domain or to some other domain, that federated computational governance should be followed. Fine. And self-serve infrastructure as a platform. Uh, I hope most of you have this question as well. How come a domain person like a sales team can can think independent of themselves? There won't be an IT person within the team. Then how can he create a data lake or a database based on his need? Right. That is the biggest question, and I'll come to that in a couple of slides. But the principle is based on data mesh practice, self-serve infrastructure as a platform is also a principle. Fine. Okay. Now, let me confine it in this way. Data mesh, data lake, data architecture. All these are very big words, right? But as an individual person, as a normal developer, as a normal tech lead, uh, I was not comfortable in understanding this, right? So in my company itself, we faced a problem. We generate a lot of data, and we need to extract the insights to prove the ROI for the softwares we are using. One thing, and we need to generate insights to drive the business as well. There were two challenges in my company itself. Okay, the example I'm going to tell is it's not exactly a data mesh problem and a data mesh solution, but the practice is somewhat related to this problem. Okay, so that it will be easy to understand, and the same happens when it comes to a bigger project or a different domain like healthcare or something else. Okay, so let me explain in a very simple thing. Kissflow is a workflow management tool, and it is built in a low code idea. Okay, so that any business user can come into Kissflow. He can design his workflow like travel reimbursement process or purchase request process. He can create his workflow, and that workflow can be used by any business users. Anyone can submit a request, and based on the design, as someone can approve the request or deny the request, and there will be some other person sitting and some other place. He'll be monitoring all these workflow, doing some analytics, and improvising the workflow. This is the crux of the product. Okay, so as a whole product, as a whole company, we have different teams. Okay, in data mesh practice, we call it as domains. It's going to be sales team, marketing team, product team. Marketing team would be doing many advertisements and running many campaigns to bring in the leads into the picture. And once those leads comes into the picture, they sign up for the product, they sign up for the trial, and that those trial users are getting marked into the CRM tool, which is used by the sales team. Okay, marketing team uses a different tool. Let's say it is Google Analytics, and sales team is using a CRM tool. Okay, let's consider it as a salesmate, for example, which is the tool we are using right now. And once the trial user onboards into a product, he starts to use. Okay, as a trial user, even you would have tried many trial products. You might use the product for a couple of days, you might leave it, or you might use it for 10 days and you might leave it, or you might use it for 3 days and you might buy it. Many situations happens, right? So from the product management team, right, where I belong, we have a setup, okay, where we track all the usage of all how a trial user or a paid user uses the product, what are all the events he's doing, what are all the features he's using, how he navigates into a feature, how he navigates into a page, how many active, how, what is the duration he's active in the product. All these analysis we some other tool is doing. Okay, we use live session and another tool for the product analytics, which is called Heap. It captures all the data and it puts into a data warehouse. Okay, so three teams are there and three teams generate data, and all three teams generate data for Kissflow product. But marketing team face difficulty in accessing sales team's data. Similarly, product team has difficulty in accessing marketing team's data. Like that, you compare. When it comes, when such a need happens, one team access some other team. Sales team would be complaining that there are many customers are signing up, but most of them are not buying. Okay, at that time, as a product managers, we'll be stepping into the picture that what kind of features are they using. We have valid features, and people should be buying that, right? We'll be arguing that. For arguing that, we need that picture, right? People from US and people from Europe the product pretty much very well. Then why can't we convert them into sales? We'll be questioning that. All this happens. All this is possible only if we get the data from sales. So and so deal comes from US, comes from respective city, comes from respective county, uses these features. All these things are there. So there should be a mixing happening between the sales data and product data, right? So this is what the problem we face: data silo between each of the team. And what we created is we created a single source of truth. We injected all the data from sales team, marketing team, product team, whichever the data that comes in, into a single source of truth, that which is nothing but a data lake, and we thought to query it back. Okay, but it didn't work well for our scenario, right? It involved a lot of time. Whatever the changes that CRM tool goes in, we need to change into data lake. Whatever the changes goes into the introduced by the product, it need to go into the data lake. And incorrect data, a lot of incorrect data, a lot of time involved. Mainly, that is the problem for us. Okay, so that single source of truth and data lake kind of approach didn't suit it for us. So we decided to think some other approach, and as a learning, we got to know about data mesh. Okay, so and we just saw the decentralized architecture. So we decided to take that idea. Okay, we pushed the important data from each domain into all the other tools. Fine. So important data from CRM will be pushed into Google Analytics and the data warehouse used by product team. Important event engagement information like feature one 10 times, active time 5 minutes, like that summarized information we summarize within this data warehouse, and that summarized information alone will be pushing it to sales team, so that sales team doesn't want to know each and every feature what a customer, what a trial person is using. They just know that okay, this particular person has used the trial product for three days. In the 3 days he has used for 20 minutes very actively, and he has did let's say 5,000 clicks. Okay, if a user is doing 5,000 mouse clicks, he is exploring a lot in the product, so he might be the potential customer. Let us invest some more time in this trial customer, and let us try to convert. Like that, we summarized the important data from each of our domain, and we pushed it across all other teams. Okay, and the advantage what happened is each of the domain, sales team, marketing team, customer success team, product team, we became independent to analyze the data and take the decisions. Okay, And a small and of course the disadvantages, we faced some data loss because all these data mapping need to be done based on a primary key, right? We have a primary key for every user, we call it as account id. We call that we use that account id to map the data across all the different tools. Okay, so while doing that account id kind of attributing, we some minor data loss happened, but we are okay with it. Okay, we lose 5% of data, that is fine, because we use the data to take the decisions. In the decisions, we are okay with that 5% of data loss. Okay, that as a stakeholders point of view, our company has, I mean, Kisflow has decided to accept that as a very minor data loss, and to fix it later on, to reduce the data loss from 5% to 4%, 3%, 2%, and 1% on the go. Okay, so this is what worked for us at Kisflow. And one more thing, I was talking about the culture, right? Um, Based on the culture perspective, what we did is, we at Kisflow, we have as squads, right? In that squad, there will be a front end developer, there will be a back end developer, there will be a person from IT, okay, there will be a person from UX team, right? So this squad owner will be responsible to drive the product, and that squad owner has resources from all the teams reporting to him. Okay, by the way, we call this as chapter. This vertically it is going to be squad, and horizontally it's going to be chapter. This chapter is nothing but IT, right? The From the IT team, each person will be present in all the squads, and the chapter lead will take care of the knowledge update, or resolving the doubts that IT employee has. I mean, IT team employee has, and all those things like this. This is the kind of work culture we had. So everything will be having resources from all the chapters: marketing, IT, sales, right? So independently we were able to vertically we were able to take decisions, and even horizontally also we were able to take some decisions, and even implementing such a kind of data mesh practice to make the domain independence also were easy for us due to this work culture. So let me walk through the slides, because I think I have 5 more or 10 more minutes around. So the basic ideology is, you'll be having the operational system data that is running the application. Okay, the data will be generated by microservice or legacy application, whatever it may be. There will be an input data port that will be receiving all the data, and that the data product. Here lies that what to say, the heart of this whole concept, the data product concept, where everything will be designed via automation. Data as a code, data ingestion as a code, data extraction as a code, like via API and all those things. Everything will be written via code, everything will be automated, fine. And there will be output data port, and via this output data port, a data consumer can consume the data. And of course, this output data port might be in different varieties: files, SQL, event based on the nature of the product. Okay, so while creating this output port, because this output port is all matters, both within the domain or outside the domain. Via this output port only the data is going to be fetched, right? So that output port has to be designed as careful as possible, uh, because this is a very simple example. If the company is very much practiced to analyze the data and get some insights via business intelligence tools, then that output port should support in some kind of SQL kind of architecture. Either it should expose as a JDBC layer or ODBC layer. Only then a BA tool can connect with it and extract some insights. Files and event based are possible, but a BA tool will be suffering a lot while such a kind of output port is designed. So this is another very small sample scenario. We all use podcast kind of softwares, right? So there will be separate the separation here, as you could see, even it is not based on team like sales or marketing. It is based on the artifacts of that product. There will be artists over there. There will be users, the like us, Spotify. If consider that this is Spotify, I am using Spotify to listen the song, then this is the users, and there will be media, the audio, video, and all those things will be there, and there might be podcast, and there may be artists who are producing this media and podcast, right? So when you consider this, to manage this podcast, of course they'll be having that podcast listeners demographic data and all those things. But for to have this demographic data, they need the user information. So from this user boundary, the data has to be accessible for podcasting. Similarly, while to create a favorite playlist, they need the users demographic data again into this picture, right? So like this, independently, these boundaries act very well. And also there should be the dotted lines, the output data port, which I have told here, which should be accessible for the other teams as well, with the governance in mind. So when it comes to Azure, so just consider that these as nodes, where each node have different data sources of by itself, and these data sources will be injected into some database or data lake or a data warehouse into this picture, and there will be data consumers present here itself. Okay, in this architecture, as you could see, the nodes are completely separated and the nodes are fully independent. All the communication happens from the central point. The governance play at this central point. Okay, in some cases this might work, but in some cases it might not, because if there is more of node to node communication, there will be a lot of traffic revolve around the central plane, right? So there might be outage, or there might be single point of failure also. There is a chance of single point of failure also, and a lot of things are happening. So this is another kind of practice in data mesh to be that can be tried out. There will be a central plane where the governance alone takes into picture, and each node between the nodes also they can communicate well and well each other. Fine. Um such that the data consumers can analyze the data, and they can get the insights within the node, and they can also consume data from some other node, and they can use it for analysis as well. So let me summarize in just a couple of slides alone. So overall, what we can see as benefits from data mesh is agility. Okay, it is easily scalable as well, and there will be one strong central governance, and the compliance will be practiced throughout all the domains or throughout all the nodes. And the domains, the domain team will become as cross functional team. Okay, sales team will not be having only the sales guys. Sales team will be having a sales guy, a guy from infrastructure team, a guy from data team. All the resources needed by the sales lead will be present within his team itself, so he can do whatever the analysis he need, and the decision making gets faster. And of course, as I told earlier, the faster delivery from the data to insights to actions happens very fast when we follow data mesh architecture. And what are the challenges which need to be overcome? Data duplication, of course it occurs, because sales team's data is getting pushed to some other team, right? Marketing team or product team or customer success team. So the data duplication occurs, and there comes into the picture of quality of data also, because as as a data guy present within that sales team, he'll be following the instructions of sales lead. He might miss out some data quality principles, right? So there is small quality adherence is there, and wider technology choices may lead to polyglot mindset. For example, a person who is familiar with F sharp language, if he leaves out of the company, then there becomes a gap. Some other person who knows that F sharp only can run the wheel immediately. So such a kind of small hindrances is there. And cross domain analytics, sales team data combined with product in data to do a very big analysis becomes a question mark here, because the complete data of sales team resides with sales data lake, and complete data of product resides with products data warehouse. So combining this data becomes a little bit of overhead. So these are the challenges which can be overcome, but the challenges exist. So she's the master of the data mesh all together, whichever the concepts I spoke. She was the creator. If you want to know further about data mesh, just search her name. A lot of videos she herself has spoken, and you can get a lot of information about this data mesh, domain oriented data, the practice, and all those things. And I thank each one of you for your patience to listen to my talk patiently, and I'm open to questions. Rajesh. So I think we have a question from Subrajit. He has asked, how can we use audio and video in Microsoft Azure Data Platform? So audio and video, even though they are data, they are unstructured data, and those unstructured data you might simply store in a data lake. Okay, once it is getting stored into a data lake, there comes two varieties of two categories there. One is that audio and video binary files, or that raw data itself. The other is metadata of that audio and video data. Both will be residing in Microsoft Azure Data Platform, and you do have some analytics tools and to play over that, uh, and to get some insights as well. So do we have any questions, Rajesh?
We have only one question, Dinesh.
Thank you, Rajesh. So can I leave the
Yes,
stage?
thanks. Thanks, Dinesh.
Thank you, Rajesh. Thank you.
Hi, we have next session. Um, unleash the power of AI on the edge with Azure Percept. I'm welcoming Marco Dalpino for the session. Marco, it's all yours.
Hi, hello everyone, and welcome to my session. And obviously, thank you to this great community that invite me to showcase my session. So, first of all, I want to thank you, everyone in the community, for giving me the opportunity to be here. First of all, very briefly, I want to also thank you, all the great sponsors that permit us to deliver this conference, even if online. But considering the great number of speakers that are present, and the huge number of tracks that are here, so I'm confident that it was a very great task to organize everything. So let me start. Who am I? Very quickly, I'm a cloud solution architect in Microsoft. And I work in this kind of technology that I show in a brief. But again, the partner that you probably already know that is supporting us, and also the other communities that permit the event has been done. Okay, let's start. What we are going to talk about. Azure Percept. Azure Percept is, as the name indicating, something is related to Azure. That, as you know, is the cloud platform from Microsoft. Azure Percept, in the specific sense, is not exactly something that works only in the cloud, but is a sort of mix. But we see that in detail after. What is the main point of Azure Percept? Azure Percept is, as I said, a combination of hardware and software, and obviously services that permit to some AI, some algorithm that we can not only develop, but we can use out of the box with the device, permit us to leverage solution for the AI in a very easy and quick way, leveraging some technologies that Microsoft already have, and also using some industry standard technology that are often everywhere. The main point is that we are talking about getting the AI or the intelligence on the edge. So what we are talking about is to use a combination of AI, intelligence, analytics that not only run on the cloud, but can also run independently, completely independently, also standalone on the edge. That's the main point to keep in mind. Let's start. Just a brief of ecosystem, let me say. We all know that the most part of the IoT deployments in the around are more or less sensor that getting data, that getting some decision, that giving information in general. But when we talk about IoT that use AI, that's the need also to have something more, to have usually some great connection, some great interface with the backends, with the cloud, just because usually you need to transfer a huge number of data, interface with the big, for example, source of data, databases, or other kind of information that are located everywhere in the world. But for specific and increasing scenario in the market, we are seeing the necessity to use the possibility to leverage simple and also not so simple scenario without having the necessity of a continuous connection. First of all, having an edge, an IoT device on the edge, permit us to react to some events that can happen with a lower latency, with a lower timing. So we could think about to have action and reaction that are much closer. Another point is to reduce the cost, because if you need to build infrastructure that connect the field with the backends, with the cloud, with good connection, with good transportation of data, you need to build, you need to use high availability connection that obviously have a higher cost. Third point that is probably one of the main, consider the point around security and compliance, because in some cases IoT devices that are continuously connected to enterprise network from wherever on the field could be easily hacked or used as a channel to attack the network itself. And is something that we see every day. So I cannot explain in a better way. And fourth, obviously, there's the great part of innovation that we need to continue to do. In the point of view of Microsoft, this aspect of the adoption of the devices on the edge has been divided in three great areas. The first one, that one named Horizon 1, that represent today's situation, is more or less to define and deploy that intelligent assets. So small devices, single devices or single application that essentially can leverage specific solution, specific application, and solve one problem at a time, let me say. Starting from this point, what we are trying to build is to build an intelligent environment of devices that could be grouped by industry. For example, if I built different solution that leverage, for example, video surveillance or object detection or inspection in general of some area that could be used. This specific topic can be used in several different industry. For example, for I don't know, the transportation, the surveillance itself, but also for logistics, also for retail, and all these different of industry can be addressed in different way, but using more or less the same intelligent assets that we are building now today. The third horizon that we are looking is to get this environment more autonomous, that can run by itself in this solution, but also can interface and leverage between other environment and communicate and exchange this kind of data that are leveraged by the intelligent solution, right, to get a higher level of information, but also automation in general. Let me describe that better after. Okay, what we are talking about. When we talk about Azure in general, we have the general Microsoft Azure ecosystem. Then we have the stacks of clouds that Microsoft have. Microsoft 365 for the devices, Azure Arc and Azure Stack for systems that are running on the edge, but they are for data center or a big environment, and the part for Azure IoT and AI, and that's where Percept is more or less located. Okay, this is some interview that Microsoft do with some of our customer, and not only our customer, in how they think is good to simplify the way to simplify the solution for the edge and the AI. Those priorities guided us in building this product, and we see how. Okay, Azure Percept is what? As the prompt is saying, is sensing, is knowing, understanding, and then acting. Okay. The device, because we are talking about a device, and I can say a set of device, permit us to sense some specific sensory capability, create some sensory capability in the edge, percept, get to understand how what is happening essentially, and from there act. Let's start. I don't want to go forward with the discussion. Let's start to see what Azure Percept is. As I said, Azure Percept is a solution that is composed by a hardware and software and services solution. First of all, what you see in this slide is the main hardware for Azure Percept. Let me point this with the laser pointer. These in the higher right that you see is the main hardware, the main board. Essentially, you can consider that like a very small PC based on an ARM CPU. that is running a Linux distribution built by Microsoft. Yes, you are here correctly. We built essentially a distribution of Linux. The name is Mariner. And with this distribution that is specifically dedicated to our Azure Stack and Azure Edge platform, we created this device in collaboration with some OEM in the specific developer kit. The first developer kit has been built together with ASUS. And more or less, as I said, is a PC with Wi-Fi, with Ethernet, and HDMI exit output, but that's not, more or less, not useful in general. What you do with this hardware, you connect the external module that are the perception module. In the specific basic developer kit, you have the Azure Percept that represents that is represented by let me zoom by one camera, and this module where you have a neural CPU is the Myriad CPU from Intel, to be clear, that leverage the operation and the AI intelligence directly there on the device. We see later how it works, but directly on the camera, you are leveraging the your solution, your AI solution, and what you transmit using the device, what you transmit on the backend, what you transmit on the cloud, on the service that you have on the back, is only the information that is important, that is relevant. You don't need to transfer all the video streaming on the backend, on the cloud, and that's a huge advancement, I think. Let me continue. The other module that we have in the Azure Percept developer kit is the Azure Percept Audio. That is more or less the same concept of the eye module, but is dedicated for the audio. The Azure Percept Audio is a microphone array of four microphones that permit to leverage a solution like audio speak recognition, audio recording, or in general all that application that need to have an audio interface. For example, something that is a customer service, or something like what happened in the hotel, where you have to communicate or act between the room and the lobby or wherever, and that kind of solution. Then the third main part of the Azure Percept is, as I said, software, because not only is the software that is inside the module, but that's also the service that is offered as a service on the Azure platform that is named Azure Percept Studio. That is essentially part now of the Azure portal. Let me go a bit in detail. considering what is inside the hardware, what are essentially the benefit? Considering that the device is built around, as I said, our distribution of Linux, it contains more or less our platform named Azure IoT Edge that permit us to leverage different container. I cannot describe better as containers of intelligence in general that can be run on the hardware. Inside the hardware, we leverage the access to Azure IoT Hub. Using Azure IoT Hub, we permit the procedure to add our device, new devices to our ecosystem on the cloud. We permit to update that over the air, for example, or update our intelligent module in the sense that we can change the inferencing images that we have on our devices right from the cloud. And, for example, changing our solution from a video surveillance to, for example, an object detection in general, just to get an example. We can also provision completely from scratch a device from the remote. And that's all managed by the Azure Percept Studio and all the other services. I more or less already described the hardware. Okay, the developer kit, because we are talking about a developer kit. Azure Percept is an hardware that we sell from the Microsoft Store. Actually, it is already available there, and the basic. As I said, the basic developer kit is the main CPU and the video board that is based at $349. For the Percept Audio, the price is $79, and can be used in combination, obviously, with the basic developer kit. Let me go forward. Okay, talking about what is integrated in the platform. The platform already integrates all the services that we in Microsoft usually named under the umbrella of cognitive services in general, but specifically we implement in Azure Percept Azure AI, machine learning, cognitive services, custom speech, and live video analytics. That is probably something that we see in a brief. As I said, Azure Percept Studio is something that permits us to not only manage the devices, but also create new inference solution directly on the cloud and deploy it on the device without having to write any line of code. Obviously, we can also create a solution that is based on our favorite programming language for the AI, Python whatsoever. But the main point for Azure Percept is to personalize, to customize, or to create a new inferencing solution right using the interface in Azure Percept. Studio. I want to go a bit faster because I want to show you how it works. I think is more important to understand looking at the effective solution and not just talking about it. What usually is the cycle of developing an AI inferencing application? Usually, you have and expressly a solution that need to run on the edge. You have on one side the embedded developer, the IoT developer that usually need to manage the device that stay on the edge, on the field. The device monitor what's happened on the field, deploy. There's a deployment and development of the models. There's a training phase of the models that has been followed by a labeling of what we are observing. And then we gather the information that are needed for the model. Usually, all these phases are done by different teams in collaboration, sometimes not in collaboration, but in opposition, let me say. But in this case, in our solution, that has been automated as something that is running directly on the solution. That permits us to create new models in a automated way, and we don't have discussion between the teams because there's no teams in this case. Let me step forward. These are some of the industry that we are thinking about when we built this device. These are industry where we see solution that can be easily leveraged with Azure Percept. To be clear, each of that have different are different applications, but more or less can be reconciled to not one, but some 3 or 4 or 5 basic solutions that are the one that basically are managed out of the box from the developer kit. Okay, what are these kind of solution? These 4 examples that you see is exactly what actually Azure Percept can do. In the first, in this first upper left image, you see how much time a person spent in a queue to pay in a grocery store, for example. And you see that the first person stay for 50 seconds whatsoever, and the second one stay a different number of time. This scenario is something that is highly have an high importance for what we actually living in this time of social distancing whatsoever. Let me also describe to you that this solution also permits to get the other information. For example, if the person that are in the queue is actually wearing a mask, or they if they are respecting a social distancing. So we can also measure the distance between each person, and also, I don't know, warn in some way if some person are closer than what is permitted by the social distance. The second, the upper right solution, is something for an outer solution dedicated to a vehicle parking. As you can see, we see the parking stalls in red when they are occupied, and in blue when they are free. And as you can see, when the first car is coming in the stall, you see that the stall changed color from blue to red, exactly because has been occupied by a car. That's a solution that permits with only one device to automate completely one parking, considering to monitor what's happening in the parking, sorry, but also managing if there are free stalls or not. And in case, give us the information of how many stalls are free, and, for example, signal that outside for a person that is coming from the outer part of the city. The third solution that we have in the lower left of the screen is a classic security and surveillance, something that we can manage easily with whatever camera. But what is changing in this solution? As you can see, in the area that I have delimited in red, when the person that is actually coming inside, when the person passing through that area, it became it became detected, and that permit me to warn somewhere, notify to someone that a person is entered in our property. The last one that I have here in the lower right part is a much more complex solution, because it fit several different scenarios. Here we have a machine inside, a big machine inside an industrial production line, where we have some person that is working around this machine. What we are seeing here, that we have a green zone that we consider as the area of this machine where someone could enter to work, and when someone enter in this area, they need to satisfy some specific condition. For example, they need to wear a specific jacket, they need to wear an helmet, and also when we see the red area, that is a smaller part, we consider that in that area we cannot have a person, also if he wear the helmet or whatsoever, when the machine has been activated. When we detect that the machine is activated and there is a person inside this area, there is a warning that is turned on, and you can see the light that is starting flash here. Obviously, is something that you can do also in other way, but in this way, you can integrate a different scenario all together in one device, in one stream, in one application. okay, that can I think can decrease the cost of the system by many values. Let me okay, this part describe what are the main points around the security. What are the points that is inside the device specifically to guarantee the security. This device is built by Microsoft with a zero trust approach. That mean that this device cannot permit any workaround to log in or to access to it or to access to the cloud. All the access and connection and transmission are guaranteed by our zero trust let me say, field of line. Okay, again on that, but I don't want to so much on this, right? Because I want to give you a small, excerpt of what's happening. Here I have a device already running. Let me shift to okay, to the web screen. Okay, I want to show you what we are talking about. When we talk about Azure Percept Studio, I said that is now part of the Azure portal, okay? And that is exact what you see now, because you see that I am on a web browser. I am on the portal, in the Azure portal, and here I have a function, a service that is Azure Percept Studio. Let me show you. If I return to the home of the Azure portal and search for Percept, yes, I have Azure Percept Studio. What I have on the what I can do from Azure Percept Studio. Essentially, I can have an overview of what I am already done with my devices, because I can also have more than one. I can manage my devices, and if I click on devices here, I can see the list of all my devices that I have deployed. As you can see, I have two of them deployed, Percept 1 and Percept 2. Actually, I see from the status that only one of my devices is connected that mean that is online, but is also connected to the cloud. That not specifically mean that my Percept 2 is turned off. Does it mean that is only not connected to the cloud? For example, if the device is using a connection that is going up one time in the day and not 24/7 all the day, I cannot see it continuously, but I can see it connected only in that specific slice of time. We see later what does it happen for the functioning of the device. Let me select, for example, my device that is actually online and connected directly to the to the portal. And yeah, I have some information. I have some general information of the device. I, from here, can skip and jump directly in the manage on the manage side of the device directly in IoT Hub, right? Because all the IoT devices like this, that is an IoT Edge device, is managed by IoT Hub. That is, if you don't know, another service that we have in Azure, where we have all the services that we need for managing these kind of devices. For example, here I am in my IoT Hub, and I'm clicking on the IoT Edge blade, and here I see that I deployed on this IoT Hub two Percept device, Percept 1 and Percept 2, exactly the one we see. But here I can look at my device on another point of view, on the point of view of accessing it, on having the, for example, the connection string. What does it mean, the connection string? With this connection string and also this key that you see, primary, secondary key, I can access also, or I can program or re-update the device also from the external, but I can also connect with my devices. But also, I can also connect to my IoT Hub point of access, right to get the information that is coming and the metrics that are coming from the device. And we see that just in a brief. Let me return to Azure Percept Studio, where we have also other two tabs. We have the tab Vision and Speech. Vision is obviously, as the name let us think, is all about managing the vision kit, the vision side of the device. And from here we can leverage all the operation related to the vision device. For example, from the first block, we can start to capture images. For example, if we are creating a new scenario, for example, we want to start to detect a person that is passing behind the camera, okay? And for example, we want to detect, I don't know, the mask on the face whatsoever. Okay, we can start to capture image from the device and encode that on our backend directly in Azure Percept. When we get a number of images that is enough, we can start the operation of tagging. Then we start to select the part of the image that we need to detect, and we also label what is represented in that. For example, if in my example, I want to detect people and I want to detect if they are wearing a mask, I can detect the person in global and also detect if they wear a mask or not. Defining that, I can in a completely automated way from here create a new inference image based for the vision. It will be based on OpenVINO framework. you probably already know the OpenVino by OpenVino is an open source project that is also personalized and customized very highly by Intel, specifically for their CPU and the Myriad CPU that is inside the Percept vision, and create a new image, inference image that we can directly deploy on the system from here without having nothing to do directly on the device. From here, I can also view what is happening on my camera. If I click on View Stream, it opened me this web view that is essentially, this is my hand. What you are seeing now is real time, my hand coming from the camera on the Percept camera. But the magic is coming now, because if I get, I printed some, I don't know if you can see it, but I printed some simple photo of object. For example, this one, let me show it behind the, oops, okay, okay, is actually not working. Obviously, the demo usually doesn't work as expected. I don't know what's happening, but let me restart it. View stream. Let me check if everything is running okay. Yes, the Azure I module is running correct. Okay. Let me open again the web stream video, and let me again. Okay, that doesn't work. I'm sorry. I tested it before starting the session, and obviously, actually, it doesn't work. Okay, what is supposed to happen? That's supposed to happen that when I show a normal object in like this picture in front of the camera, it tell me exactly what to recognize and the level of let me say the level of the percentage of agreement of that is through. For example, if I show the cup, for example, like here, it says me describe a rectangle around the cup. It delimitate the cup and write the number, for example, 06, 07, 09. That is the percentage of feeling that is effectively a cup or not something else. Apologize for doesn't work. Actually, I don't know what's happened in the meantime. But what I can also show you is, in this case, let me close this one and return from here. What I can also manage from directly from here, from IoT Hub, as I said, is the updates. For example, if I want to update with my personal modification, if I get some modification to the operating system, to some specific module of Percept, because consider that Percept is available for free on GitHub, I can recompile it by myself, and from here, from the updates that I can manage from IoT Hub, I can pull my new images and flash it directly on the system when they come online. Obviously, from here, I can also send updates that is coming from Microsoft, for example. That will be delivered directly to the devices. Okay, we are, I think, at least at the top of the time. So let me go to the end of the presentation, actually, because I want to leverage how it works about the devices. Azure Percept is not only a device that is built by Microsoft. Microsoft is only built the developer kit, but is offering that to external OEMs and builder that could certify Azure Percept devices to put on the market. These are, okay, the actual availability, and the distributors that actually could could sell Azure Percept around the world. But important is that these partners and OEMs are actually building their own Azure Percept system in order to cover specific scenario. I don't know, for example, for healthcare, for industry, for transportation. So each of them are building actually Azure Percept devices that will be by the hardware more dedicated to specific scenario, and you can in the very short future select for your specific application. Let me go very fast to the end. At the end of the slide deck, I have put the summary sources that is essentially the main page of Azure Percept, and also the repository of Percept on GitHub, where you can find all the sources of all the modules, and you can, as I said, change or make personalization and whatsoever. Let me check if there are some questions. Hello. Let me see how we can use. Okay. I don't know if these how we can use Edge in SDN and OSS. I honestly don't have this answer now. But you can reach me offline, and I can give you the answer for sure. Consider that basically the edge device have connection, okay, obviously with Wi-Fi and Ethernet, and permitted to use different kind of protocol, not only the standard TCP, HTTP. And you can also interface with your network also with different protocols or transportation way. Obviously, in the developer kit, it's all based on TCP/IP on internet, but some of the OEMs that are building new devices are also thinking about to use, for example, low-level protocols for communication. Let me see if there are other questions. No, it seems that there is no other question, but If you want, you can also obviously I please leave feedback, because it's very useful for me to understand if I do something useful for you, and also for the organizer to understand if you are happy with this session. And here are some of my contact. You can contact me via Twitter, or via the About Me, where you find my contact. Please, I probably cannot answer immediately, but if you contact me offline, I try to give you an answer as soon as possible. I want to thank you, and hope to see you all next time. Thank you. Thank you. Thank you. Let me check if we are okay.
Hello, everyone, and welcome to this session about artificial intelligence. My name is Salvatore, and today I will talk about artificial intelligence and how it is shaping the front-end world. So let's start. This session was originally intended to be had by me and Michele, but Michele will not be here today with us. So I will do my best to have this session alone. So before starting, what even is artificial intelligence? Well, a textbook definition will be that artificial intelligence is the effort to automate intellectual tasks based on tasks that will be normally performed by humans. But how does it work? Well, let's explain first the traditional programming paradigm and how it does work. We have an algorithm. This algorithm runs on the input data, and with this, we have the result, which is the answers that we expected. With machine learning, that is a new programming paradigm. We have data and answers. Based on this data and answers, we can generate a new set of, we can generate the algorithm, and that is called machine learning. With these two inputs, we have basically created a model. Model is a set of rules that can be applied later to a new set of data to generate new answers. These answers are typically called prediction. Let's make an example. Here is an example, simplified example of a machine learning model used to classify images. We have here a network that can classify images on 4 classes. We have the dog class, the bicycle class, apple class, and tennis ball class. The image is split, and mathematical functions will process this data to extract some feature from the images. And these features are used by all these layers of mathematical functions that and these features will be used to classify the image in the correct class. Later, when we had trained this network with a bunch of images, of already classified images, I will pass it an image of a dog, an image of a bicycle, an image of an apple, and so on. Later on, we can pass it new images, such as the image of a bicycle, and the network will be able to classify it in a different class. In this case, we have the network is 93% sure that this image is really a bicycle. So it's not certain. We have not a certain answer. It's just a probability score that is applied to that input data. Machine learning at start can be quite difficult. It's something that you can study, you must study, and if you want to ship a product faster that leverages some kind of functionality provided by modern machine learning algorithms, you can leverage something like the cognitive services, which is basically machine learning as a service to build these functions in your application. And today we will build these functionalities in our front-end applications, as to show that a new way of interacting with our application is possible when using the cognitive services. To get started, we can use the pre-built AI services made possible by the cognitive services. These services come ready out of the box. You just use it as a service. We can use the Azure bot service to create conversational artificial intelligence applications, and that will be discussed later in this session. or when we are ready for custom algorithms to run custom models, we can leverage the power of the Azure platform to run these models on custom-built hardware that will speed up the process of making such a model. Regarding Azure Cognitive Service, we have different services, different APIs in different groups. We have service for the vision workloads, for example, face recognition algorithms. We have form recognizer, computer vision, general computer vision, so image classification, video classification, and so on. We have services related to the speech part. We have speaker recognition, speech to text, text to speech. We have the language analysis on the language analysis section of the cognitive service, which analyzes human language and text, basically text. We have decision algorithms in the decision section, such as anomaly detection, content decision, personalizer. And then at last but not least, we have a bunch of different APIs to manage the search in the web for different items, such as news, images, videos, and so on. Today, our main focus will be the speech section and the language section, and how these services can be combined to create a new way of interacting with applications. So the first thing, we will see the speech services. Speech services contain, as I said, a bunch of different APIs we can use. There's the speech-to-text API, which can be used to transcribe audio, human sound, human voice in text. We can later convert this text back to audio. So we have a bunch of different phrases, text, and we can speak it in a human, natural, human-sounding language, human-sounding voice. We have speaker recognition. Speaker recognition is able to recognize in a big audio file or a live stream of multiple people talking who is speaking and when he's speaking. So it can recognize different voices and classify it automatically without training. Then we have speech translation, which is another cool feature that is able to translate speech in real time. We can translate speech from a language to another in a real-time fashion, which is very cool. These services come ready out of the box, but we can improve it and customize in different ways. For example, for the speech-to-text service, we can create an acoustic model. This model is created to improve recognition based on the user's language style or user's environment. For example, if the user wants to use this service is in a noisy environment, we can create a custom acoustic model that will filter out this noise and so on. We can create a custom language model to add specific language expressions, which are not readily available in the general model. We can create a pronunciation model to create custom templates for words that are not already present in the global model. Custom acronyms, product names, and so on. Another cool feature is that we can leverage the power of the cloud to create a custom voice based on audio recordings of a person. We can create a new voice, a voice that is custom for our application. Regarding the speech synthesis service, it comes available out of the box in more than 45 languages, and we have more than 75 voices spread across those languages. These voices come both in a male and female voice, and we can choose between standard and neural voices. The standard voices are traditionally computer-generated voices. They sound less natural than the neural voices. The neural voices are generated with machine learning algorithms under the hood, so they are more natural sounding. They sound more human. We can also customize the pronunciation, speed, volume, and pauses of our text. We can do this by writing text by decorating our text with tags in a similar way of HTML. So instead of adding the bold, italic, underline tags, we can add text to modify the speed, the volume, and so on. And this is done in a standard format called SSML, which is very similar to HTML. Okay, these features have interested us. We want to use this, but how can we implement it? There's a bunch of different ways. All these services are available as RESTful APIs. We can use these APIs in whichever way we like. If we want a library already built, there's an SDK for that. This SDK is available in many programming languages. And this SDK under the hood leverages WebSocket natively to provide the real-time streaming or real-time translation way of interacting with these APIs. If we want to create our custom device that leverages these services, we can use the speech device SDK to create our custom device that has these functionalities built in. So let's see a quick demo of that. I have built a Blazor application here that uses the Cognitive Service SDK. As you can see, I have here a client application, which is our front end, and this is a Blazor WebAssembly application that is talking to a backend, which is completely called by an API, so it's not a traditional MVC application. I here have created a server. I already imported the correct NuGet package for the SDK. What I need now is an Azure subscription, and I have to create a cognitive service resource. I already created that. I can use this key. Put it here in the settings, settings. I have to choose also the region. I'm in Italy, so West Europe is the best choice for me. And we will speaking and listening to voices in English US. This configuration parameter will be used for synthesizing speech. We will be synthesizing speech in English using the neural voice called ARIA. I've created a controller, standard controller that accepts two kinds of requests. Let me close that here. Okay, I have this method that accepts a form file. This file will be an audio file in WAV raw audio format. We'll be passing this audio to our speech recognition API, which runs in the cloud. Once the audio has been recognized, we pass it again to our client. Second method is the opposite function. We have a synthesized text method that will accept a text request and will generate the audio with the voice we have seen before. So if anything goes well, I hope I'm sharing the audio. I'm going here in the server application. Let me run that. And once it is ready, we have it running here. Let's make a quick refresh. Okay, so now I'm talking and the service hopefully is picking up my audio. Okay, so everything worked. Let's try to synthesize this text.
Okay, so now I'm talking in the service. Hopefully he's picking up my audio.
Okay, so if I configured my streaming right, you should have heard that. And if not, I assure you, it's 100% the truth. A lady told me what you see here on the screen. To do that, to do the recording part, in this demo, I used Ready library, which is called Amazon Lex. This is part of the Amazon Lex SDK. I used it for simplicity, but we will then, later in this demo, we will implement an alternative to this library. Basically, what this library does is start recording on click, and then when the silence is detected, it will call my endpoint here, passing it the body, no, here, passing it the audio file to the backend. Well, everything worked. So these were basically two cool features about the cognitive service, which can provide a more rich interaction with our application. But we can do something more with our voice. And if we think of modern voice assistants, that is naturally immediately comes to mind, and that is voice activation. Voice activation is typically built with systems called keyword recognition. And basically what they do is they allow us to wake up applications by using our voice. These systems are something that users are already accustomed using. So they are very familiar. Just think of any voice assistant like Alexa, which is quite popular today, or Siri or Google, and it's you understand it's quite famous and quite familiar now. These services are, as I said, they are typically built with machine learning. Machine learning technologies need to be reliable. They need accurate model, and this is to provide a satisfying user experience. The accuracy of the models are measured by measuring the false positive rates and the false negatives rate. We have a false positive when the application wakes up when it's not intended to. And we have false negatives when the application doesn't wake up when it's supposed to. So we try speaking to Siri or to Alexa and it just doesn't wake up. Building such a model from scratch can require time, expertise, also lots of data recordings, but we can leverage something like the cognitive services to build such a model for us. The keyword recognition system in the Speech Studio portal has one big advantage, and that is that no audio samples are required. We are just required to provide the service with a short word or phrase, and the model is generated for us, no machine learning knowledge required. Then, when the model is available, we can use it we can use it with a bunch of different languages. We have SDK for C#, for Python, and in the Apple world we have Objective-C and Swift. These languages are thought with both desktop and mobile applications in mind, so we can build applications for both mobile and desktop platforms. There is only one big disadvantage as for now, is that this model is currently only available in English and Chinese. So if you speak those languages, it's fine, and if not, you gotta take another system. With the Speech Studio, we can generate two types of models. We have the basic model, which is ready in less than 15 minutes, so it's suited for demo or rapid prototyping purposes. We can iterate fast and try different keywords, see how they work, and so on. And later, when we are ready for production environment, we can build an advanced model. This model is much more precise, but it can take up to 48 hours to build, so it's not something that you can generate fast. Let's see together what are the steps required to building such a model on the Speech Studio portal. I already done that, obviously to keep my demo short. What I did on the Speech Studio portal, I created a project, set a name, set the language, in this case the English language. Then I've chosen my keyword. Microsoft suggests the following guidelines when choosing our keyword. The word should be kept between 4 and 7 syllables. It should not be a common word, so something that users could say in day-to-day speech. Something like "OK computer" should be fine. And so I've chosen "OK computer." The wizard then shows us a series of possible pronunciations. We can listen to these pronunciations and uncheck the ones we don't expect our users to say. And this is done to improve the false positive rates or the false negatives rates. Then we choose the model type between the two different models already listed before. And then when the model is generated, it's downloadable as a zip file. This zip file will contain a binary file with the model.model extension. I have already done that for time reasons, but what I can show you is that we can create desktop application by just using 4 lines of code. Here I've created a simple console application. I already downloaded my keyword model here. I have already imported the same SDK. I'm using C#, so we have the same Nugget package. In this case, I'm using the .NET 6 version of the framework, which is in release candidate 2, by the way. It's fine also for production use. And with .NET 6, what I can do is write a minimal console application, so no program class or static main method required. In this case here, I have imported my keyword recognition model from the file. I have created an audio source based on my default microphone input, so it should work fine even when streaming. Let's hope so. And then later, I'm starting my keyword recognition system in a recognize once fashion. So I now can move to my console application folder. I can run it, and we can see that the application is not waking up. But if I say "OK computer," then the application wakes up and greets me, "Hello, hello everyone." And as you can see, doing a desktop application or a mobile application for what it matters, it's quite easy with this SDK. We can then later use the speech-to-text API, which is included in this model, as we can see later on in this demo, to build something like a virtual assistant, a voice assistant. But what if we wanted to run this in the browser? As of today, there is not a ready-built solution with the cognitive services, at least. What we can do is, just for the sake of the demo, we can put our keyword recognition system in the backend. We can transfer the audio stream from the client, which runs in the browser, to our backend. The backend will run both the keyword recognition system and the speech-to-text service, as to provide some kind of functionality to our front-end application. To do that, we need some tools in our arsenal. First of all, inside our client, we need a way of detecting when the user is speaking. So we need to do noise and silence detection inside the browser. Second thing we need to encode this audio on the fly without locking the UI thread, without making our application feel sluggish. And to do that, we can leverage something like the Audio Worklet API. This API is a standard web audio API. As such, it's supported by most desktop and mobile browsers available today. It's not a problem even with Safari on iOS, so it is fine. No libraries required. We just need to extend from a base class provided by the browser. We will see that later in the demo. And what the audio worklet allows us to do is to process the audio stream directly in a dedicated thread. So we are not forced to do that in the UI thread. We incur no risk of making our application feel sluggish. This will be all run in a dedicated thread. The second thing we need to get this model running in the backend is a bidirectional channel. A channel that supports streaming data back and forth from the client to the backend. In particular, we will need to stream the audio data to the backend, which will be streamed in a binary format. And then we need to receive the partial responses from the backend. As the text is being transcribed by the speech-to-text API, which, by the way, this service is able to do that in a real-time fashion. So as we speak, the speech-to-text service will provide us with the transcription in real time, so we can see the text forming before our eyes. Much more like the keyboard on our mobile phones and something like that. A bidirectional channel that supports both those scenarios exists. It's not the most optimal way of doing that, but SignalR with a few tricks can be made such a solution. SignalR is a library that provides us the ability to implement remote procedure call APIs, and similar to gRPC. And what SignalR does is that provides native integration with ASP.NET Core, which is obviously our favorite choice of our favorite network web framework available today. And SignalR integrates perfectly with ASP.NET Core, and it supports bidirectional streaming. And this is done even in the browser by leveraging WebSocket. And this is in contrast with gRPC. gRPC does not support with the browser, does not support bidirectional streaming. We will stream bytes. We will have a binary stream flowing through the client, from the client to the server, and then we will receive partial responses from the server to the client. Natively, SignalR it uses JSON, which is a text-based format, and it's not ready for our use case here. But we can use something like message pack. SignalR supports many serialization format. They are not available in the main NuGet package, but we can install it as a plugin later on when we need it. Message pack is a binary serialization format, and as such, it has less overhead compared to JSON. JSON, as have I said, is a string-based format, so even binary data must be converted in a string using encoding such as base64, and that carries on a bit of overhead, both in computation and payload size. Message pack has less overhead, less computational overhead, because it is designed to allow for very fast serialization and deserialization. And also, since binary data stays binary, we have also less payload size, so less payload overhead. And this supported officially by SignalR. So there's a NuGet package we can install to support the protocol. This service solution, so it becomes something like this. We will have the audio worklet running in the browser that it's listening actively to the user's microphone. This audio data will be analyzed by the audio worklet, and then later on, when the user will start speaking, the audio stream will be sent to our backend via SignalR. The backend then starts the keyword recognition system, The keyword recognition system will recognize the keyword, and if the keyword has been spoken by the user, the speech-to-text service will be called, and partial data will flow from the backend to the browser, and then the client can show us the text in a real-time fashion. I have prepared a demo for that. This demo will be much more fun than the demo before we've seen before. So what I must do is to check out my third stage branch. I already done that. So we will go. Let's take a look at the code. I have implemented here my audio worklet. My audio worklet is basically a class which implements some kind of noise and silence detection algorithm. Not production ready, but it can do the job here. I'm extending the audio worklet processor class. This class is provided by the browser, so no library required, as I said. And what we did basically is to overload this method, these process methods. Audio data from the microphone will be put in this inputs parameter. We are analyzing the first input and the first channel of the microphone input. So mono data, single channel data, it's fine. And also what is also needed after detecting sound and detecting silence is that we can encode the audio directly in this thread. So the process method will be called in a separated thread, that is the audio worklet thread. And what we can do here is we can downsample and encode the raw audio data from the microphone to a WAV file. Here I have chosen the most common and most supported format for the services we are using. The keyword recognition system by default supports a web file with 16 kilohertz sample rate, 60-bit depth, and mono channel, so single channel. And I have encoded the audio in the format it is required by this service. This audio worklet is started by the microphone class. Media recorder file is basically a wrapper around the standard audio APIs provided by the browser to open the microphone. Here I can create a media stream source. A media stream source is created from the navigator media devices get user media key. This call will basically notify the users that the application wants to listen to the microphone, wants to open the data. And if the users accepts the notification, then the stream will be ready. We can then create an audio processing pipeline. And at the end of this pipeline, we will put our audio worklet module. The module is needed to be in a separate file. This file will be downloaded by the browser and managed by the browser. So we cannot choose when to load and unload this worklet. The worklet will be managed by the browser. We can create this worklet node. We are passing it a callback, which will be called in our application to publish the data to our SignalR hub. And what it does, this audio process callback, is basically this. I have changed my implementation a bit. I have here an audio process callback. This callback will be called each time a new data is available from the audio worklet. So after all the process calls, the process methods calls of the audio worklet, this callback will be called, and I will have inside the data passed to this callback, I have if the sound is being detected, if the silence has been detected, and also the audio data already encoded. I can later on pass this audio data to my Blazor application. My Blazor application is this. I let's take a look at the client here. I have already installed the SignalR client and the message pack client. This is basically the page component. This JavaScript, this C# callback will be called by the JavaScript client via Blazor interop, and I'm pushing the data to a class, a helper class, which I created here, the speech hub class. What this class does is that it opens a hub connection, a connection to our SignalR hub by specifying some characteristic about this connection. I have added the support for the message pack protocol. I have also forced the system to use a WebSocket transport. SignalR supports many transports. It can support polling, it can use server sent events, but for bidirectional streaming, WebSocket is a must. So I have forced it to use WebSockets. And also, since we already know the transport we're going to use, I disable the negotiation of the transport. So skip negotiation has been set true. I start the connection. I start the RPC call. This RPC call accepts a channel, which is a way of streaming data in SignalR. And later, when the data is available from the microphone, will be streamed via this send chunked function to our client, to our hub. Speaking of the hub, I have basically what I have here is a speech hub. Let's find it here. I have the server application here, and I have a speech hub. The hub is basically the equivalent, the SignalR equivalent for controllers. So I have a public class that provides two methods. Maybe a single method. That is the speech recognition method. This method is called by the client application via the name, so speech recognition, and accepts a stream of byte chunks, byte arrays, and this is understandable because we have the channel reader class. So we have a channel reader for byte array types, and then we return to the server, to the client, a stream of speech result. Speech result is just a standard object providing two properties. We have the text as it is being translated, and the keyword recognized flag, which is a Boolean flag, if the keyword is being recognized or not. Quite simple. Just for the sake of the demo, this code is not optimized. It's simpler, but not optimized. I am reading I'm reading all the audio data in a memory stream, and then I'm using this memory stream to start the keyword recognition system. In this case, we have a bit of a mix-up from the two methods we have seen before. I'm here creating my keyword recognition model, and I'm using the audio stream format as I know how it is encoded by the audio worklet. I've decided it's 16 kilohertz, sample rate 16-bit, and so on. Then I'm passing this stream to this helper class, which basically adapts basically an adapter class. I'm passing this audio stream to my speech recognizer, and what we are doing different this time is that we are not starting the keyword recognition one shot, but we are using the continuous recognition API. And this is done because with the keyword, with the continuous recognition API, we basically can register some event handlers. These event handlers will be called when, for example, when the keyword is being recognized, when the speech has been recognized, and so on. We have a bunch of different events that we can handle. And I'm handling these events by sending data to my client. So I'm using the rider here. This is the channel rider, the rider part of the channel that is sent to the client, basically. And what I'm sending here, new instances of this object. So I'm sending if the keyword that's being recognized was the text that has been recognized, and so on. If I've done everything correctly this time, hopefully it will run. Let's wait for the building. Oh, I'm in the console application, so it doesn't work this time. Go here, .NET, and compilazione means compilation or building, by the way, in Italian. So little Italian trivia for you. And while, okay, it is now ready, we can go here, make a quick refresh. And as we can see, I've created another tab. I'm starting the microphone, I'm starting talking, and then say, okay, computer, what's the weather today in New York? The keyword has been recognized by the backend, and also the text has been translated in almost a real-time fashion. We can, as I've said, this is not optimized, it's not production-ready code, but it works. It works, and it's what it matters for this demo. Let's stop it here. And as I've said, we can do some improvements to this code. For example, we could encode using the audio worklet. We could encode the audio in a compressed format as to further reduce the number of bytes, number of data, the quantity of data sent to our backend. We could also run the keyword recognition in the client. That is the most optimal way of implementing that. As of today, this keyword recognition model is not available in the browser, even when running WebAssembly, is not available yet. But what we could do is that we could use something like TensorFlow or the JavaScript library of TensorFlow to run such a model in the browser. Just for the sake of an example, there's TensorFlow.js provides different examples you can run in the browser. There's, for example, the speech commands model. This model is capable of recognizing up to 18 English keywords. These keywords are recognized in the browser and are keywords like the numbers from 0 to 9. We have up, down, left, right, next, previous, go, stop, and so on. These keywords are already recognized by this model, but we can teach it new tricks. By using transfer learning, what we can do is provide the model with new audio samples. These audio samples will train a model based on the current knowledge of the model. So by using transfer learning, there is not required to have a very big number of audio samples. Just 10 samples is fine. And this mostly works. It works for a demo, but it's just a proof of concept. Can be improved in many ways. This model should be adapted to your preference or to your use case. So do your own research before implementing it. Well, enough talking. We have covered the speech services, the speech service APIs that interest us. But what about the text that we have acquired with the speech-to-text service? What we can do with it is to analyze it. As I've said before in the first slides, the cognitive services provide also text analysis APIs, or better, natural language processing APIs. Let's make a few examples here. With the text analysis endpoint, we can run different algorithms like the name identity recognition. This algorithm is quite useful when you want to disambiguate between the different meanings of a word. Just for simplicity, the example, if I say I was in Washington yesterday, a human listener will almost immediately understand that Washington is a city in America and not a person. But if I say Washington was elected in 1789, then a human understands that Washington is not longer a city, but is a person. And we can use this algorithm to disambiguate between the meaning. So it can understand the phrase and the meaning of a single word. Another cool trick that we can do with text analytics is sentiment analysis. This algorithm basically allow us to analyze the sentiment of a user towards certain arguments in a phrase or in a long text. For example, here I have the review for a hotel room. I have written that I love this room, but the bed is small. So I love the room. I'm showing positive sentiment towards this subject, the room, but the bed is small, so I don't like it. I have a negative sentiment for that kind of subject. These are not all the only things that we can do. We can do also syntax analysis, so analyze the syntax of the phrase. We can do part of speech tagging, so tagging each word, if it is an adverb, a verb, an adjective, and so on. And what these services allow us to do is to gain some kind of insights in the text that users are writing or are saying. But when building intelligent applications, these services must be integrated. Such a solution already exists. It's called LUIS, and it stands for Language Understanding Intelligence Service. This service, what it does is basically it allows us to understand natural language in a simple way. It's already built as a service. Under the hood, it uses all the services we have seen before. So text analytics to provide some kind of insight in the user's phrases. These user phrases are called utterances. And basically what they are is the user's requests that are submitted to this service. And LUIS is quite useful when we want to build application that can withstand a conversation with a user. So we can understand what the user is saying, what the intent is, or what are the subject, the subject the user is speaking about, and so on. And another cool feature of LUIS is that it can do all of this, and it supports active learning. So while it's holding all these users' requests, it can generate logs. We can then analyze those logs with the user requests, and we as human operators of the LUIS application, we can choose which phrase is correct, which phrase is not being correct, and we can later we can improve actively the LUIS understanding of the user phrases. LUIS works with basically two important concepts. We have the intent concept. The intent is basically insights, information about the action to be taken by the system, what the user wants the system to do. And we have the default intent, which maps to I didn't understand. So any other intent will be put in the default intent, but we can create many other custom intents by providing example phrases. We will provide these phrases. LUIS will run machine learning algorithms to build understanding of the language model. But LUIS provides also pre-built intents. These pre-built intents are capable of managing different kinds of conversations, like calendar or communication intents. For example, there are models which already know how to understand set a note or send an email to Mark, and so on. We can import these intents in a very fast way. We will see that in a moment. The other important concept with LUIS is the entity. The entity is basically information about a certain subject inside the phrase. For an example, we have the utterance, book a flight to London. It's clear that the intent is to book a plane ticket in this case, but where to? we want to book a ticket to London. In this case, London is an entity of geographical type. It is a city. Lewis can understand entities of different types. We have simple entities, which are mapped by giving it examples of words. We can create composite entities made by different simple or single entities. We can create lists of entities. We can use patterns to help Lewis understand better both entities and intents. Or for custom codes, something that is custom to our application, we could use a regular expression kinds of entities. As for the intents, even with the entities, we have a range of pre-built entities that can be understood by Lewis immediately. Lewis can understand number entities, temperature values, phone numbers, URLs, dates, and so on, emails, and so on. Let's take a look at a quick demo of that. I am required to check out the new branch, which is the 4th branch. What I do need here is obviously the subscription key, which I have already here. Then to use the text analytics endpoint, we need this value here, this endpoint. I'm using the same endpoint both for text analytics and Lewis. And since they are in the same resource group, they are using the same cognitive service resource, so the endpoint is the same. The last value I need is the value of the UID of this application I have already created. Culture, we have chosen the English language, and I have already created the application here. This application can understand some intents. I have imported these intents in this section. I have the pre-built domains. I can import the weather domain, and all these intents have been created for me. We will be using the weather query, weather intent. So there are a few example phrases with a few example entities already imported for us. And what I need to do to use this application, once it has been built and published, is the application ID. I'm just going to paste this here. I'm going to run this application, and as you would expect, I have imported another NuGet package. I have it here. I imported both the text analytics package for the text analytics Azure service and the language Lewis runtime NuGet package. The app is running, so we can go back here, make a quick refresh because the app changed. And I can say, okay, computer, what's the weather like today in New York? The key phrase has been recognized. The phrase has been translated into text, and now the text analysis will run on the service. As I've mentioned before, this is not production-ready code. It can be optimized quite a bit, so it is not really that slow. It's just my code that is bad. The first two sections, we have recognized entities. We have the text analytics, named entity recognition recognized that we are talking about a computer, which is a product kind of entity. I am talking about today, so I have today an entity of type datetime, and I have talked about New York. The key phrases in this text, the arguments which I am talking about, are New York, computer, and weather. The second section here is the result of submitting this query to the Lewis application. Lewis understood that I want to check the weather value. So the intent that has been recognized is this. It has been recognized with a 77% accuracy score. So Luis is 77% sure that the user wanted to run this intent. And also, in addition to the intent, we have some entities that have been predicted. We have a first kind of entity, which is a datetime entity that is of type date and resolves to this value. So today has been already translated to a date, which is the current date. And then we have a geography type of entity. New York is the value of this entity, and its type of it is a city kind of entity. These entities can also recognize something like countries or roads or cities and so on. Let's take a quick look at the code here. I have basically what I did is to improve this method by simply sending the result of this method. This method calls both the recognize entity API of the analytics client and the extract key phrases of the analytics client. I'm taking the results and putting it in a speech result object that I will send later to the client, and then I'm running Luis. I have created a prediction request based on the utterance the user has said. I am logging the intents, and I'm asking the service to provide me with all the intents. So we have the list of the accuracy score, the prediction score for all the intents, even if they are very low. I have then parsed the intents and then the entities, which have been provided by as a result from the service. This was enough demos for today. We have seen Luis is something that we can leverage to build a real conversation with users. Having a conversation with the user is typically done with a chatbot or a bot, which is a modern type of human-machine interaction. It's something that today is quite popular. It's something that can be used to automate simple and repetitive tasks with our users. They allow to automate application processes, so we can create bots that will notify us of something. Like for an example here, we have a bot that can automate the notification sending about delivery of packages. These bots can be written to answer single shot questions or establish real dialogues. And with something like Luis, this is much easier to do. Also, one big advantage of chatbots is that they don't require a new application. You don't need to build a new application to provide functionality to your users. Users can use some chat application they already know how to use, like Facebook or WhatsApp, Telegram, and so on. They can use something they already know to interact and engage with your application. To build such a bot, Microsoft provides a solution that is called Bot Framework. This framework was started as an open source project from a company. Then Microsoft later on acquired it. Not the project, the whole company. They acquired the company and kept the framework as open source. With this framework, what we can do is to integrate all the services we have seen today. So the speech services and the language understanding service, also custom vision, custom service like Q&A, which will be talked about later in this track. And this can be done by engaging with the users in different channels. There is a bot framework via the Azure Bot Service, supports Teams, Skype, Facebook Messenger, emails, SMS, you name it, you got it. So there are many channels you can use it to interact with your users. To get started with such a system, there are templates written in both in .NET and JavaScript. So you can these templates, you can study them to get the hang of what the bot framework is about. There are very different samples, so to cover all the use cases you would have. You can test this bot with the bot framework emulator, which is a client application you can use to interact with this bot locally. So you don't need to publish it on the cloud to test it and develop it. You can do it locally. There are also a bunch of tools that you can use to implement something like the application translation, so the localization and the Lewis integration and so on. Check it out. So that brings us to conclusion. If we sparked your interest in these subjects, we are blogging about artificial intelligence on our blog. You can check this blog on www.elico.com. We are blogging in both Italian and English, so it shouldn't be a problem. You can also subscribe to our newsletter. We promise no spam. We will just blog about and mail you about news from the AI world. That's all for today. These are my contacts, also Michele's contacts. If you want to hang out if you want to answer me something, ask me something, I will be in the YouTube chat for a while, or you can contact me on social media. Thanks again for having me, and see you later.
Okay. It looks like it's my turn now. Okay, let's see. All right. Hi, everyone. I'm 2 minutes early. Okay. So today I'm very happy to be here, and I hope that you're having a good time there where you are right now. So today I will be talking about serverless in how to jumpstart your serverless applications or .NET development with Azure Durable Functions. And before I start, I would like to introduce myself. I'm Jonah Anderson. I am a software engineer, Microsoft MVP for Azure, a certified trainer, a mentor, and also a community leader of Azure User Group Sweden. On daytime, I work as an IT consultant at Forefront. And today I will be going through some basic concepts to help you jumpstart with serverless computing, and specifically in durable functions. So I will go through what it is, the basics of Azure Functions, durable functions, the different patterns that you need to know to solve some complex problems. I have a mini demo and a few use case examples and some learning resources. So before I start, I want to share with you this airport key problem. So we have been locked down at our homes or working from home for the past years because of the pandemic. And definitely soon when the world opens up, there will be lots of queues at the airport. And sometimes when we're at the airport, we wish or we hope that we could do something else while standing on the check-in line. We wish that we can buy and grab a cup of coffee without losing our state in that line. But sometimes we have to. And that's also the same thing with programming. So when I was studying programming, Java development, one of them, I encountered this story about the dining philosopher's problem. in which there's a scenario of 5 philosophers, 5 forks, and a philosopher needs both fork from left to right in order to eat. Otherwise, he can't. So just like in programming, in this kind of scenario or problem, there's a problem of deadlock, which means that if a philosopher picks one fork for both left and right, then no one can eat, and it can also cause starvation. And that's the same problem when we're handling parallel tasks in our applications or development. And I hope that this session will give you insights about serverless computing and how you can solve it using durable functions. So before we go there, I know that most of you, since we're all developers, have the basic concepts of cloud computing already. As we all know, there are different deployment models. We have the typical from left to right. We have a typical on-premise private cloud where we have everything in one place for all layers. And then we also have infrastructure as a service, and then platform as a service, function as a service or serverless, and software as a service. And today we will be focusing on function as a service or serverless. It's what's it's called. So I want to compare serverless in a sweet way. So it's when it comes to from left to control and to the right productivity. So in monolithic architecture, we have it's like layered cake. So you have all layers in one place: the data, the database, servers, applications. So you have more control in that cake because it's all in one place. And then the microservices here, for example, is like cupcakes. You have different flavors in small portions. And it's just like also creating mini services, for example, for handling user actions or CRUD operations. So that's microservices. And then serverless, there are like small candies with special flavors in it. It's very light, and you can just put it in your pocket quickly and easily. So that's the same thing with development with serverless. Your productivity increases. I mean, the more you work with serverless, because the infrastructure are abstracted from your tasks, which means that actually it's not really serverless because there are servers behind it or infrastructures behind it, only that the cloud providers like Microsoft Azure's AWS or Google Cloud Platform are abstracting or taking good care of that for us, so we developers can focus on productivity and less on maintaining on those infrastructures. So me as a developer, we have these problems with, for example, like the dining philosophers problem. We have the concurrency problem, racing conditions problems, deadlock. And as a developer, it can be kind of tricky and complicated to debug this kind of issues in development. So if there's a need, there's a solution actually for such problem, and that is using serverless solutions or function as a service solution like Azure Functions. So for me as a developer, I love serverless because I can solve complex problems. I can build modern apps, and it makes me productive as a developer because I don't need to worry about upgrading the systems or servers from time to time. I just focus on what I want to deliver through development. And what are Azure Functions? So Azure Functions is actually a serverless compute in Azure. It's on demand, it's pay as you go, which means there's a consumption plan for that in Azure. It's event driven, which means that this is special and dedicated to event-driven applications or architecture. So if your business requirement isn't event driven or doesn't require you to have that, then probably this is not the right one, right technology for you. But it's event driven, and the purpose or the good thing about Azure Functions is that you write less code, because you don't have to take care of the other stuff in the infrastructure, and development productivity, and it can be integrated with other services in Azure as well as other APIs. So basically, Azure Functions is a combination of code, our logic, what we write as developers, and also the events and data. And the events can be triggers, what's happening. For example, a blob trigger. Your function app can be triggered by a blob trigger, Azure Cosmos DB trigger, HTTP trigger, and your data can be input and output, what you want in and out in your logic. And what are durable functions? So durable functions is not it's not the enemy of Azure Functions. It's actually, they're like sisters. So durable functions, they work together with Azure Functions. So it's an extension of Azure Functions. And the purpose of having or using durable functions is that it allows you to run stateful and stateful workflows in a serverless environment. And it is also an Azure Compute Service. And the good thing about this is that you get more productive. Compared to just normal Azure Functions, is because durable functions, it's stateful, and it allows you to manage and take care of the state for you, so you don't have to worry about that. And the technology behind this is the Durable Task Framework, which you can check if you want to see the code base of that. You can check it out on that link. And you can also code it with your favorite languages like C#, JavaScript, Python, F#, and PowerShell. For me, I code .NET mostly and a bit of JavaScript. So you can choose any language that you want. And before you can get started coding durable functions and create workflows, it is vital to know the different types of durable functions. So there are actually 4 types. The first one is client functions. And the client functions, they're like the starting point of the orchestration. They are like the events, the trigger. For example, HTTP trigger, the blob trigger, and an IoT trigger. So client functions calls or kickstarts the orchestrator or the orchestration. And the orchestrator itself plays a vital role in the workflow. The orchestrator is where you design your workflow, your tasks, what you want to do in your orchestration. For example, depending on the type of pattern or problems that you want to solve, of course. So this is where you design your workflow. And we also have another type, which is called activity functions. This is where you put your deep work of logic in here. So in every task here, you can, in one of the tasks, you can send emails, send an SMS, save data to Cosmos DB. So those are the tasks that you do in your orchestration. And here you can put in your configuration and everything. It's more free. I'll share more about orchestrator later on. And so the next type is the entity function. So entity functions, they are special types because it's specially used for CRUD operations for durable entities. And the special about it is that you need to use entity trigger if you want to use this function type. And currently, as far as I know, it's supported on durable functions above 2.0. And so far, it's in .NET and JavaScript. So what differs Azure Functions from durable functions? So Azure Functions are stateless and durable functions are stateful. So those are the two differences, but they work together, and they're useful depending on what the type of problem that you're trying to solve. And the orchestrator is a very important type in durable functions, because this is where you write your workflow, your stateful workflow, what you want to do. And it is important that we code or design it in a deterministic way, because it's deterministic, which means that you have to be like logical in what you want to do. Why is that? Because the entire workflow will be replayed. So you cannot have, for example, infinite loop in your workflow, because it can cause problems. And for more information about deterministic API, you can also check it out on this link. So here's an example of deterministic versus non-deterministic, or without orchestrator. So here, as you can see on the left side, that's the durable functions. We have an orchestrator in which you design your workflow to do this and that in certain order, or depending on the pattern that you want to have. And then on the right side, you see here that like group or isolated Azure functions, the normal ones without an orchestrator. So for example, one of this function or function up belongs to a different resource group, maybe, and the Azure VM, the VM in Azure was restarted for some technical reasons. So that will lose its state, and another function may be dependent on that. So if you don't, so that's one of the disadvantage of not having a workflow. But of course, it depends on the type of problem that you're trying to solve. And when you're designing an orchestrator workflow or the workflow, there are documented code constraints, and here are just some of them. So, for example, from left, these are the things that are not recommended. And then the blue one here to the right are what we should be doing instead as developers. For example, one example here is that it's not recommended to put or to code GUIDs or random numbers in the workflow. And then what you can do instead is to have to use the new GUID method if you really need to generate IDs. And also not put any database configuration or connection strings in your workflow or orchestrator. What you can do instead is you can pass in your configuration in your activity function itself. And blocking APIs, not good to have in the orchestrator. What you can do instead is use the durable orchestration context that has a prepared method for you to use to keep your workflow stateful. And of course, don't create infinite loops in your workflow. I mean, in your orchestrator. It's because especially if you're on a consumption plan. So there are two things. First, you will get, if you create infinite loops in a deterministic orchestrator, you might encounter some problems in there. And of course, the other side, the business side of it, is that if you're doing that and calling several functions at the same time, you might get infinite bills in your Azure as well. So don't create infinite loops, but if you really need to, you can make use of a method in the durable orchestration context called create as new. And no current datetime in orchestrator. What you can do instead is use the method current UTC datetime in the orchestrator if you need to. So there are detailed documentation about the constraint. There are some more actually on this link below, so you can check it out as well. So The next step, aside from doing the different, knowing the different types, for example, the client function, orchestrator, the activity, and the entity functions, it's also good to know the different patterns, known patterns at least, for the Azure Durable Functions. There are actually 6 of them. First one is the function chaining. The next one is fan out, fan in. And then we have the human interaction pattern. We have the monitor pattern. We have the HTTP API here, and then this is the human interaction pattern, and we have the aggregator pattern. So the function chaining, the first pattern is called function chaining. So in function chaining, you execute a sequence of functions in a particular order, like a chain. So the output of function 1 is passed into function 2, and so on and so forth. And this is useful if you have a chain of actions or things to do in your application. So here is an example that we have here. This is an action. Function chaining is action. For example, if you have an HTTP trigger or a blob trigger, when that event happens, your orchestration will be started, and activity 1 is scheduled. And when it is scheduled, the orchestrator sleeps. And then when the orchestrator sleeps, activity is done. And then the orchestrator wakes up. The activity 2 is scheduled. The orchestrator sleeps again. Activity 2 is done. Orchestration completed. That's for 3 activities. And the entire workflow will be replayed. And the good thing about durable functions or using the orchestrator is that when the orchestrator sleeps, it's a good thing, because you are not being charged for other activities that are not working. So you only pay for what you use, and you can control it using the orchestrator. All right, so here's an example of a hello sequence workflow that I borrowed from the Microsoft documentation. So here we have a sequence of greetings that's called hello sequence. This is in C#, and we have a list of strings that prints out hello greetings to different cities worldwide, and it returns the output string. So it's pretty a simple example. And the next pattern is the fan out and fan in. So in fan out and fan in, you execute you execute parallel tasks at the same time, and aggregate and wait for the results when it is done. And this is hard to do in normal functions when they are not stateful. So this is a good example. For example, for a code example here, backup site content for the orchestrator. In here, you have a directory of files. You get the directory, and you have a string of files that you want to back up. And you go through the loop here, and you call an activity, loop through all the files, and then call the activity called copy file to blob storage. And then when it's done, you actually use in the code the keyword, the function name when all, and pass in your tasks. And then when you're done, you return all the tasks or what type of data that you want to print out. For example, in this case, they wanted to have the total bytes of the files that were backed up. And the third pattern is the async HTTP API pattern, which means that I hope that I'm sharing the screen. I hope that one. Okay, that one is right. Okay, sorry, I got a bit distracted. Okay, so async HTTPI pattern. So here we have This is useful if you want to have async methods with APIs. For example, long-running operations with external clients or APIs. In this example, I have a method that I created long time ago or a while back about this pattern, in which I have a method called check if my website is available function. And in here, I have a durable context, a workflow in a try-catch block. I have my URL for my website, jonahanderson.tech. And I create a method I'm creating a durable HTTP response. This is the keyword or class that you need to use if you're doing async HTTP API pattern. And in my context, I'm calling a method call HTTP async. I choose the type of HTTP method that I want, and I passed in my URL, and this URL can be an API URL, so not just a website. And when you have the response, you can set your conditions. If that response is good or not, then you can throw in the HTTP request exception error, or you can process the content of that response farther, depending on what you want to solve or do. So that's async HTTP API pattern. The next pattern is the monitor pattern. So it's useful as the word itself. It's for monitoring recurring processes or flexible workflow that, for example, periodic jobs like this. So in here we have monitor job status example, in which you have a while loop that checks on the expiry time. You have a timer that checks on that. And then what you do is that you check on the status of your monitoring of your workflow. And if that's completed, it's going to send an alert, call an activity to send an alert. And then while it's not completed, it's gonna like the orchestration sleeps until this time. So it keeps checking using a durable timer to perform the tasks long running and stateful. So that's the monitor pattern. The next one is the human interaction pattern. So in this process, this is useful, especially if you want to create approval workflow that requires approval from a human being. So this is useful because you can actually use a durable timer along with it, inside of it. So in this example, we have a request for approval, in which you send in a request to a human being, to a person. It can be a manager or someone that needs to approve certain tasks. And when that person approves, then you process the approval. However, that person might be somewhere else having a vacation or not working for that day. So what you can do is you can create a durable timer or a timer in which that checks if that person doesn't reply, what you can set a timer to escalate it on a specific period of time. And this is how it looks, the approval workflow. So you have a request for approval in which you wait for external event. As you can see here, you have a durable timeout using the context create timer. So that's a durable timer. You pass in your due time, your timeout token. And in here, you have an approval event. In here, you have a Boolean that keeps checking if you want to, waiting for an external event. And that external event can be any of them, an approval from a person or a timeout. And depending on which comes first, it will be processed, otherwise it will be escalated. So that's the human interaction pattern. The next one is the aggregator pattern. So aggregator pattern, it's useful for stateful entities. For example, if you want to aggregate event data over a period of time, and it's coming from different resources, and it can be addressed into a single entity. And this is not easy to do in normal entities because they can lose its state. And if this is an example of that. So here we have a durable entity context in which you have your entities and you have your methods, and here you call the method signal entity async with your entity ID, the method add in the switch case, and then passed in some data. So that's an example of stateful entities. And in durable functions, you can also create, even though there are 6 known application patterns, you can actually create your own customized pattern. It's because durable functions allow us also to create sub-orchestration in an orchestration. So in this example that I have here on my PowerPoint, I have like an orchestrator, and in my orchestrator I have 2 sub orchestrations, and in each sub orchestrator I have different activities that does its task. So this can be like as big and complex as you want, and you can call it whatever pattern that you call it. But the most important part here is that don't make it too complex, and keep your orchestrators deterministic in your workflow. And as of now, as far as I know, the sub-orchestration is only available in .NET, JavaScript, and Python, not yet in PowerShell. And this is an example of sub-orchestration in the code. So if you can see here, another example from the documentation that I borrowed, we have a function named provision devices. And in here, I have a list of strings for device IDs, and I have a method that get those device IDs. And I can go through the loop of those IDs. And what I can do is in each device ID, I can call another sub-orchestrator by using the method call sub-orchestrator async and the name of that orchestrator, and you passed in your data, for example, your device ID. And then from the orchestrator, you can process it farther. And then when everything is done, you can combine actually the pattern, which is the fan out, fan in. As you can see here at the end, it uses task when all and all the tasks that were completed. And then the next one is developing. How do we get started developing with Azure functions and durable functions? So it's actually easy. You can get started now if you want. So all you need is just an Azure account. You can actually start creating Azure functions on the Azure portal. Or if you're into doing command lines, you can also use the Cloud Shell, the Azure CLI command on the web browser, or even locally. And if you, for development environment, you can use Visual Studio, VS Code. That's for C# because I'm a .NET developer. And in order to develop locally, you would need to install the latest version of Azure Functions core tools, which you can download from this link, or you can also Google it. It will come up on the first page or list. And if you're working with web requests or HTTP triggers, it's good to have Postman, especially locally, to see what's going on with your requests. And otherwise, if you don't have Postman, you prefer the old style web browser, you can also do that. And locally, I recommend using Azure Storage Explorer. So your function app is actually connected to an Azure storage. So when you create a function app, you need to set up an Azure storage account as well. And in that Azure storage, there are tables, or there are data that are stored for those tables, like your instances and things that you need to know when you're running your functions in the backend. And supported languages, so you don't have to be like expert in all languages, but there are supported languages that durable functions or Azure functions provide. So it's pretty flexible and diverse. So you can choose any of that, and there are guides on how to get started. So when you want to full stack development with Azure functions, it is actually possible. I mean, even though it's like backend as a service or function as a service, you don't need to code a GUI or a UI. You can actually combine or do full stack development with Azure functions. For example, Azure Static Web Apps, you can create React, Blazor, or Vue.js in that. And in your Azure Static Web Apps, you can there's an API support for that with Azure functions. Or what you can do also is you can also bring your own functions and implement that in your Azure Static Web Apps. And as for the orchestrator, this is what I mentioned when you're checking it out on Postman, for example, or in your Azure storage. There are this information or properties are pretty important to know, especially if you want to log or know what's going on behind your orchestrator. Sometimes you need to debug and find out why things are not working. So it's important to know that you can actually you have control as a developer. So in the logs, you will see that there's an orchestration instance ID. So when you trigger an orchestrator, you get a random instance ID, and you have different links like the URL of your orchestrator, its instance, how the URL that you need to use for terminating, purging the history, and even restarting your orchestration instance. So those are the things that are good to know. And as far as integration, you can integrate a lot with Azure functions. For example, you can integrate with Azure Logic Apps, Event Grid, IoT services, database services like Cosmos DB, and more. And you can also, that's a good thing about serverless because it's flexible. You don't need to, you're not limited as a developer. You can also integrate it with external APIs, in which I will be showing in my demo as well, a combination of both Azure and external APIs. And you can also deploy your serverless functions in containers and also container services like Azure Container Registry. And you can create boots with Azure functions. So there's you can sign up for a developer account for a Twitter. And you can use Twitter API to create Twitter boots and automate your workflow there and lab or do hands-on with that. And great other integration possibilities. And if you're into deep Azure functions container development, you can be aware that there's a technology called CADA, Kubernetes-based event-driven autoscaling that you can use with Azure Functions runtime, and it works pretty well with Azure Kubernetes for containers. And coding durable functions, what are the good practice or good to know? So I recommend using Azure Application Insights for monitoring or logging, and conscious versioning. It's since it's stateful workflow, it means that you cannot disturb the workflow that's long running. So when we have to make changes on a task or activity in your function app, It's good to have conscious versioning by making use of the deployment slots, for example, for dev, staging, and production. And another option is to do side-by-side deployment so that the production is not interrupted. Deployment with breaking change, and also make use of the tools available like Service, Azure Storage Explorer. There's a good article that I recommend sharing about the green deployment strategies by a developer. He made a study about durable functions and strategies in developing it. So that's the link there. You can check it out later. And error handling. So sometimes it's hard to handle errors in serverless, but there are actually ways how to do that. So if you encounter an error, the typical exception that you get is the function failed exception. And what you can do as a developer to handle them is, of course, you can try to try-catch block, the normal ones that we have. But you can also use the different methods. Like, for example, there's in the orchestrator, you can use or call the method call activity with retry async, and you can set your conditions there. Alternatively, you can call another function activity to handle things if things doesn't work based on your condition. Up insides, and there's also a new one. This is pretty new, new development add-on, which is called a durable functions monitor that you can check out in an open source repo here. An automatic retry looks like this. So you use the call activity with retry async and the name of the function that you have, and then you can set conditions for your retry options. And here you have a condition that you want to retry max number of attempts 3 times, and also the interval. So you have control as a developer as well for that type. And the typical try catch. So we developers do logging, but you can also do this for your orchestration. You can call another activity async. So in this example, transfer funds. So you have a debit and a credit. And if things doesn't work, what you can do is you can credit back the account to the user or to the owner of those money. So yeah, so that's the exception. Try catch example. Next one is the unit testing. So part of our job as a developer is to create unit tests. So you can actually create unit tests with serverless functions or Azure functions. What's supported? It supports mock and the typical XUnit, frameworks that we use. So you can create unit tests for your orchestration, or you can also create unit tests for each activity. So this is an example of that, and there's more in the documentation. And here, deployment. So when you this is an example from Visual Studio. So when you deploy, for example, you have a lot of options. You can deploy it using the Azure Cloud Shell, the Azure CLI. But if you're working locally, you can just get started using Visual Studio or VS Code. And for example, in Visual Studio, you can actually publish it directly to Azure as long as your account is logged in locally. You can publish your function app in both Windows, Linux, and you can also publish or deploy it as an app container or Azure Container Registry. And then CI/CD, this is something that you can set up as well. So you can have it using your pub XML file, or if you want to use the CI/CD using GitHub Action workflows, you can generate YAML files here as well. So that's a good one to save some time. So now is a demo, but before I show you some code or some real live example, I want to show you what my demo is about. So I have it on my GitHub as well, but the demo that I want to show is that the flow looks like this. So I have an Azure Blob trigger that will be triggered when I upload an image on my Azure storage. And then when it's triggered, it will start an orchestration. So the orchestrator starts working and it wakes up. And when it wakes up, it will pass in the blob image data that I have from the image that I uploaded. And what it will do, it will send a message to the service bus queue. It will save that info. And then when it's done, it's going to send an SMS and call via Twilio to me as the administrator of the Azure storage. And then it will also send an email to me using SendGrid. So this is a workflow example for function chaining. And here we see that a good example as well, that you can integrate durable functions or Azure functions with both Azure services and external APIs like Twilio and SendGrid. So what I expect as a result is that I will be getting an SMS, my message or data, a blob image, a queue message will be saved on my service bus. I get an SMS, I get a call, and I also get an email. So before let me just switch, let's see, let me just share my screen. Okay, let's see. So here I have my code. Let's see. So this is my code here. Let me show. I have some time. Okay, so here's my code, which is in Visual Studio. A very simple example called durable storage. And what I did is I actually organized my functions. So here I have the orchestrators, the client functions, and my activity functions, my tasks. And the starting point is the client functions, which is my trigger. So in here, I have a blob trigger that uses durable orchestration client. And I have the name of my container on line 18, my connection string. And in here, I have a try-catch log. I do some logging. And I check if my cloud or blob is null or not. And then I have actually created a model, a class for this, kind of like trying to work object-oriented way. So I save it that way. And what it does, this is the special line. Line 39 is a special one because this is where I save or I create this is where I call my orchestrator. It uses the starter, which is the durable orchestration client, and start new async. So that's the name of my orchestrator. And what I do is I passed in my blob data. And in my orchestrator, what I have here is my workflow. So I have my orchestration context in a function chaining pattern. I check if it was empty. And what I do is my first chain is to call the method send message to Azure service bus queue. And I pass in that. And then when it's not null, I'm going to do my chain 2, which is to call SMS to Twilio, pass in my service bus message. And I have my chain 3. When I have sent an SMS and made a call to the user, I'm going to send another notice, which is send an email to the admin using Twilio. I know that this can be done in logic apps, and it's kind of like lots of like connection. But my point of this minute demo is to illustrate that it's possible to combine different services in Azure as well as external APIs. So I'm going to run this test so you can see how it works in action. So I'm gonna have this one, and I have my local Azure Storage Explorer here, and I will also open one of my photos here. So I'm gonna try to upload one of them in my photos container. And when it's done, it should trigger my orchestration here. So I see the backend logs. So right now it's transferring. So let's see. So here it shows that it's doing its work. And I'm also getting SMS and call at the same time, and also an email. So without checking the details of what's in the email, but I can see in the back end here on the log that that I am, let's see maximize. So here you see the timestamp in here. So here I have started executing the start. I triggered it with a blob trigger with this image name. This is the blob name. I started my orchestration with this instance ID, and executing the first task. I received the event data, and so on and so forth. So I'm logging everything of that with timestamp that I can also see in here in my storage. And in Azure, I have actually published this in a resource group in Azure. And I have a service bus called Durable Storage Notifier. And in that, if I refresh here, let's see, I can go there instead. So in my queues, okay. And in my Service Bus Explorer, let's see if I receive something. I have several messages because I was testing this already. So I'm going to do a pick in one of my messages. And this should be, one of them should be here. So the messages are here, and I can process it later to maybe create another web app to show those images in the front end. So that is my demo. Let me just present again here. Let's see. Okay, let's see again. So those were the expected result. So that's the expected results, and I'm glad the live demo went well. And before I end my session, I want to show you another use case example also of serverless, the power of serverless in Azure cloud security. So I personally have been involved in helping out a bit with this project called Cloud Katana by Roberto Rodriguez. It's an open source project by Microsoft that they uses Azure functions, specifically durable functions in PowerShell, to simulate attack and defense in Azure, especially with Azure AD. So if you want to contribute, I know that Roberto is looking for contributors in this security world in the cloud, so you can check out the links there. And I also want to share that recently I changed computers. Since this is a developer-focused conference, I want to share that when I changed computers, I had to install Azure Functions Core Tools, the latest version. I have Windows x64 bit, and I got this error on Visual Studio, the debug executable error. And I Googled it, and I couldn't start my function. I thought there was something wrong with my code. And then I found out that the cause of the problem was this folder, CLI. And what solved the problem is that I had to edit the name of the folder to CLI_64. And then when I did that, I could run my functions locally after I cloned it again, and it worked pretty well. So if you encounter that problem, you can definitely just go to the local map or folder and edit it to with something with x64. And let's see, the next one would be learning resources. So if you want to learn more, there are a lot of great resources in here. So Microsoft Learn and Azure Functions, and Azure Functions University by Mark Duker. So he has a great playlist for beginners about it. And the Azure Serverless community libraries with great use case examples and how you can get started with Azure Serverless. And lastly, I also organize events for Azure User Group Sweden. So if you're interested to speak, share knowledge in my community here in Europe, feel free to scan the QR code to speak and join us in that community as well. And lastly, I want to thank you everyone for tuning in to me live and recorded later on. And if you want to connect and ask questions about my session today, feel free to do that using the information here. And also, we want to thank you to all the sponsors of this conference, Microsoft and Elastic and EY, and our other partners as well. So thank you so much. And I'm ready for Q&A if there's any, or if the time permits.
Hey, John. Thanks for your wonderful session. It's
Thank
great
you.
presentation and demo. Thanks a lot. So
Yeah,
we
thank
don't
you.
have any questions. So maybe further questions, it came from YouTube. Maybe after session, you just look at the YouTube channel. Okay.
Yeah, I will do
Yeah.
that. Yeah, thank you so much. Have a great
Yeah.
day.
Great. See you. Thank you.
Bye-bye.
Bye.
Hello, can you hear me? Okay, hello and welcome to my session about Azure Sentinel. Before we start, I'd like to give you a short introduction about me. My name is Hannes Lagler-Gröner. I'm a multi-cloud architect in one of the biggest consulting companies in Austria named ACP IT Solutions. I'm working since 2012 with public cloud, mainly focusing with Microsoft Azure. And over the time, I'm realizing it's a good idea to go more broad and also specializing into GCP and AWS too. You can find my social profile in Facebook, Twitter, LinkedIn, Xing, and whatever. I have for sure my private YouTube channel. You can see it also here. And since 4 months, I'm also a Microsoft MVP, and I'm really happy about the graduation from Microsoft. Okay, but enough from me. So let's start with the agenda from today. Today we talk about Azure Sentinel. Azure Sentinel is the modern CRM system based on Microsoft Azure. We have here an agenda for today. The agenda is really short. So we go first of all, we go to the topic, why Azure Sentinel? Why should we use Azure Sentinel? Why should we migrate from traditional systems, from traditional CM systems to Azure Sentinel? Then a next step here, how to start. How can we start with Azure Sentinel? It's a really important topic here. I will give you a short overview about the most important steps. And for sure, we have many, many live demos where you can see, okay, how Azure Sentinel is how Azure Sentinel is working with SOA mechanism, with automation and so on. Okay, so let's start to the first discussion. Why Azure Sentinel? Before we go a little bit deeper into the topics why Azure Sentinel, let's think about in the past, when we are implementing a CM system into your environment, we have some starting discussion points. And here I've listed some main starting discussion points. The first of all is, okay, we have many services outside your company network. For example, IoT sensoric data, and we also want that sensoric data in your Azure CMs, in our CM system. We want to protect our devices outside the company network. It's a little bit hard in the old-fashioned way, in the old way. When you have your CM system on premise, you have to add API to your system. Also bring the API outside the company network and so on. The next topic here is for sure right sizing. Right sizing is a big problem in legacy or in old-fashioned CM system. You have to think about, okay, how many data should I transfer to a CM system, and depending on that couple of data, you have to think about, okay, what's the right size for my CM system. Another point is upfront investment. Upfront investment means, okay, you have your CM system, you have to pay, for example, for licenses, maybe for your hardware and so on. And you need an upfront investment to implement the CM system in your environment. And for sure, I have many projects in to migrate traditional CM system to Azure Sentinel. From traditional CM system, you also have some problems with an automation, lack of automation. Okay, these are some discussion points. And let's think about, okay, how can Azure Sentinel help you to fix those discussion points? First of all, your services are outside your company. No problem in Azure Sentinel, because it's a cloud service. You have your connection point to the cloud. So we have different connection service. We have different options to connect sensoric data. We have different options to connect VMs and so on to your cloud system, to your Azure Sentinel in the Azure cloud. So we will see it a little bit later. The next point, CM right sizing. Azure Sentinel is not an infrastructure service system. Azure Sentinel is a platform as a service system. So this means it scales to support your growing. So when you transfer today 5 terabyte and data to Azure Sentinel, no worries. It's okay. You can transfer it. When you transfer tomorrow 1 terabyte of data, you don't need much lesser on hardware, it's no worries. So we think about, or we talk about an Azure PaaS system. So we don't have to think about the right sizing. The system behind Azure Sentinel is scaling automatically for you. Upfront investment, we don't have any upfront investment. You pay what you use. We have here a pay-as-you-go concept for Azure Sentinel. So when you transfer today 1 terabyte, you pay for 1 terabyte. When you pay tomorrow for 5 terabyte, you pay for 5 terabyte. So pay-as-you-go model. Lake of automation. So I can say here, I don't find any limitations. So we are using automation or playbooks. We have two different areas here. Playbooks means we are using Azure Logic Apps, and you can automatic everything what you want. So you can automatic tasks in Azure Active Directory, in Azure, in Office 365 on-premise. So there's a mass of automation here available. So let's go a little bit more into the details from these discussion points. First of all, disconnected services. We have here a PaaS system. So you can use Azure Sentinel, including the artificial intelligence behind Azure Sentinel to get faster threat detection. You have the ability to connect your services outside from your company, from everywhere to Azure Sentinel. So there's no worries about this. This is an Azure PaaS system hosted in Microsoft Azure. But, and this is the most important part here, when we implement Azure Sentinel, we always need an SOC team. So we need a team which who manage Azure Sentinel. So Azure Sentinel doesn't make everything for you. So you need your analysts, you need your SOC team, you need your security personnel, and so on and so on. Important part here. Next point, right sizing. We have here a limitless cloud speed at scale. So if you need more resources, you get more resources. You don't need to implement more hardware or to pay for more hardware. You get it because it's a PaaS system. It's a CM service available in Azure portal. So it's really simple to implement a CM system or Azure Sentinel to implement. Take up to 10 minutes for the basics. And then we have to think about the next step. So we will see this in a few seconds. This it scale automatically. So you don't have to think about compute storage resources or whatever. It's a PaaS system. So it's really scale automatically for you. About the upfront investment perspective, we have no infrastructure costs. We have you only pay for what you use. So you say, okay, I have my log analytics workspace, I have my Sentinel on top to log analytics, and you pay for the ingest data into Azure Log Analytics and into Azure Sentinel. So that's only what you have to pay. But over the time, you know, okay, I have, for example, per day, I have 100 gigabyte data each day. So you can use a capacity reservation. So you can also say, okay, I have a reservation. I'm using reserved instances for 100 gigabyte per day, for example, and you get an 50% discount for Azure Sentinel. It's also possible. It's really flexible. It's a flexible model, so you have no upfront commits. You pay for what you use, and when you know, okay, I use 100 gigabytes per day, you can implement a reservation for Azure Log Analytics and Azure Sentinel too. So a really cool option, a really cool model here to pay, and you have no upfront investment. Other aspects are also you have no infrastructure setup, and important, there's no maintenance. So we are speaking about a PaaS system. It's really, really important here. It's a faster threat protection because you can use the artificial intelligence behind Azure Sentinel, and you can also build your machine learning concepts with notebooks, with Jupyter notebooks, and it's also an important part. The artificial intelligence behind Azure Sentinel learns from each incident. So It's really important to define the incident. It's a true positive, it's a false positive, because in the back end, Microsoft or the artificial intelligence learn about your incidents. It's really easy to integrate with existing tools. So think about, you don't use only Microsoft Office 365 services or cloud services. You have for sure also your on-premise environment. So we always think about hybrid cloud scenarios, and you also want to implement existing tools or existing logs from other systems. It's really easy to integrate, but we will discuss this in a few seconds. Other aspects are the Microsoft security advantages. Microsoft invests more than 1 billion annual investment in cybersecurity each year. It's really important for Microsoft. So Microsoft is protecting their data center and also protecting your services, your environment with this investment. Microsoft has more than 3,500 global security experts, which only look at, okay, is the data center safe? Are the incidents or are the artificial intelligence good enough? And always increase the security for you. They have trillions of signals, trillions of diverse signals for unparalleled intelligence. So it's really important. Microsoft learns from your signals too. So you also profit from other customers, so from other informations from other incidents here. Okay, so let's go to the topic, how to start. From my point of view, there are 6 important steps to start with Azure Sentinel. First of all, not 6, it's 7 when you define, when you think about everything here. The first step, and this is the most important step, define your use cases. Define use cases, what you want to know from Azure Sentinel, from Azure, from the CM system. Define the use cases. Based on the use cases you have to define your data collections. You have to define what kind of data do you need to achieve the use cases. Then we can think about the implementation of visibility. It's really important. So you have your data in your environment. You also need a visibility. You have to know, okay, is everything okay in my environment? Are there any anomalies available, and so on. Then we can go to the next step, implement and use analytics rules. So we come in a little bit later to this topic. Then also a big part is hunting rules. And at the end, when we have analytics rules, it also creates an incident. We need an incident handling. We have to know, okay, how we can start with incidents, how we can use incident, how we can add commands and so on to incident. And at the end, when we know, okay, there are some use cases available, and if this use case happens, we want to automatically block, for example, the user, we have to implement an automation task. So these are the most common steps that you have to use to start with Azure Sentinel, and it's really important. So let's go a little bit deeper to the topics here. The first thing is collect data. So we have different options to collect data from on-premise or outside your company network. We have for sure the options to implement Microsoft Azure, the Azure portal, or the Azure activity logs or security alerts from Azure. Also for sure for Microsoft 365, it's really important to implement also Office 365 or Microsoft Office 365 data, security alerts, the activity data into Azure Sentinel. And on the right side, you can see Azure Sentinel is built on 2 services. The basic or the main service is here Azure Log Analytics, and on top to Azure Log Analytics you build Azure Sentinel. That's really important. The next one is for firewalls, for example, or for other systems. You can implement common event format, the CEF format, or for sure syslog. You can also collect data from, for sure, Microsoft Windows environments, Windows 10, Windows, or Windows OS, what you have, what you want, and also for sure for Linux environments. At the moment, we have 2 different collector types here for Windows and Linux. We can use the old or the legacy way with the Microsoft monitoring agent, so we can use in the near future also the Microsoft Azure monitoring agents, the new AMA agent, but at the moment it's only supported in a private or in a public preview. Then we can use external service with text2 or Microsoft Graph indicators, the thread indicators. You can also implement text2 information to your Sentinel environment. And at the end, we don't have only standardized systems. We also have sometimes custom systems where the logs are written, for example, in a separate database or written in a log file or whatever. And we also want those information in your Azure CM system, your Azure Sentinel, and you can use separate APIs to transfer those information to Azure Sentinel. It's important. It's also possible to do this. Okay, that's from the data collect part. One important topic here: Microsoft Azure activity logs and Office 365 activity logs, also alerts from Microsoft Threat Protection, are for free. So you don't have to pay anything for those logs. You can enable Azure Sentinel, enable those data collectors, and you have the information inside Azure Sentinel, and you don't pay anything for this. It's really important to know. The next point is implement visibility. To implement visibility, you are using Azure Workbooks. Azure Workbooks is nothing new. It's not only available in Azure Sentinel. You can find Azure Workbooks also in Azure Active Directory or in other systems. There is for sure a huge gallery available for predefined workbooks, which you can use based on your data collector. So this is an important part. You can use workbooks, and these workbooks are bound to the data which you have collected before. You can write also for sure your customized workbooks based on gallery workbooks. You can customize those workbooks, or you can write from scratch your own workbooks. It depends on your need. And you have here a really cool environment where you can bring information from Azure Sentinel, from Azure Log Analytics, or also from other systems like Azure Security Center, for example. You can also bring those information to your workbooks and get them visibility to your management or visibility to your analytics colleagues. The next point here is implement analytics rules. Analytics rules is the first step when you have your data, when you have your visibility, to react on different signals or react on alerts from other systems. So it's really important. Analytics rules are also based on your data which you have in your environment. And there are more than 100 built-in analytics rules available which you can use. So no worries, you can implement those rules and use it. But first of all, we have to think about define your use case, define your data, define your visibility, and then start with analytics rules. You can write for sure your own analytics rules based on KQL queries. So it's a separate language. It's not really hard to learn, but it's a huge language. So you have many options here, and you can implement those rules in your environment and create your own incidents. You can also for sure create or connect other Azure services. For example, Microsoft Cloud App Security or Microsoft Defender for Identity to Azure Sentinel. So you don't get any data from those systems. You get the information, okay, there's an alert available in Microsoft Defender for Identity, and I also open an incident in Azure Sentinel. We will see this in the first demo in a few minutes. Then we have to implement hunting rules. Hunting rules is also based on KQL queries, so you can write your own hunting rules, or you can use the built-in hunting rules. There are more than 100 built-in hunting rules available. The screenshot behind, screenshot here is an older one, so we have more than 100 hunting rules. We will see this in the live demo. But the question is, when should we use hunting rules? Normally, we are using hunting rules before an incident occurs. So we want to check our system, our environment, predefined. or during a compromised situation. So you have a compromised situation and you want to know, okay, where is the hacker? Is there some other systems where the hacker is logged in or whatever? You can use live streams in your environment. So this is running in the backend, and you get an information about, okay, this live stream rule is occur at the moment. An important part here, the difference between hunting rules and incidents. Incidents are scheduled, for example, or based on other services. Hunting rules are always manually rules. So you have to manually start hunting rules. And the other point here is hunting rules are not able to connect other services. So you're using the data from your log analytics store. And the third option that you have, or when you should use, is after compromise. So is everything okay in our system? Is the hacker maybe away from our system? You can check this with hunting rules too. Okay, that brings me to our first demo. First of all, I want to show you Azure Sentinel, a short overview about the Azure Sentinel. Then we go one step further, and I will show you how easy it is to implement, for example, Azure Active Directory to your Azure Sentinel, which is for free. Then we go to the connectors, to the workbooks. I will show you the predefined workbooks. I will show you also customized workbooks with third-party services connected. And at the end, we are going to analytics rules, how you can write analytics rules, how you can use predefined analytics rules, and also for hunting rules. Okay, so let's go to our environment. Here we are. This is Azure Sentinel. Azure Sentinel, once more, is based on Azure Log Analytics. So you see here your Log Analytics workspace. Selected workspace, Log Sentinel demo. So this is my Log Analytics workspace. And based on this workspace, I have implemented Azure Sentinel. This is our overview. In the overview, you can see how many events are collected, how many alerts do I have in my environment, how many incidents have available. Here you can see an overview about your data, how many data are collected over the time. And one important part when we think about Azure Log Analytics, the default configuration or the standard configuration is the first 31 days are for free. So you're collecting your data and you are storing the first 31 days. When you implement Azure Sentinel, you can increase your slider to the first 90 days. It's for free. So when we go here, this is the view for the last 24 hours. We can increase this to 30 days or use a custom range the first 90 days. And it's also for free, the first 90 days, the data collection. You can increase the slider to maximum 730 days in Azure Log Analytics, but you have to pay over for each month, for each gigabyte per month for over 90 days. Okay, on the bottom, you can see your potential malicious events, which are available from outside your company network. On the right side, you see all open incidents and data anomalies. So, okay, then the first step, normally it's here, you can see any data because Azure Sentinel, there are no data connectors available per default. The first thing what we have to do is we have to implement data connectors. There are different data connectors available, not only from Microsoft, there are always also third-party data connectors available. And you can see in a few seconds, we are here in a live demo, in a few seconds, which data connectors are available and how you can implement this. You can see here there are different available, Microsoft, third-party, and so on. And I have some data connectors available in my environment. When I switch here to, come on, it's a little bit slow right now. Let's refresh the portal. I'm sorry for that. So, come on. Okay, now it's ready. So you can see here, we have some data connectors available in my system. We have the Azure Active Directory, and I will show you how easy you can implement Azure Active Directory data connector. So let's select the data connector, open the connector page, and you will see here, okay, you can choose from different data sources or for different kind of data sources, log types from Azure Active Directory. For example, you want to know, you want to implement the sign-in logs in your environment, the audit logs, and so on and so on. And what you have to do is you have to select your logs, click on apply, and that's everything. When you do this, click on apply, the data will be collected, and that's it. It's really easy. So this is a data collector based, okay, you get the information from Azure Active Directory and store those information in Azure Log Analytics. But there's also another data collector available when we have a look to Azure Active Directory Identity Protection, which is another service. When we go here to this data connector, we need a license. We need the Azure Active Directory Premium 2 license to use this connector. You can see it here. And the only thing what you have to do is you have to connect. I'm right now connected in my environment, but you normally you have here a connect button, and that's everything what you have to do, nothing more. So when you can do this, you can connect Azure Sentinel to Azure Active Directory Identity Protection, and when there's an alert, when the alert occur in Azure Active Directory Identity Protection, you also get an incident if you enable here the incident creation. You also get an incident in your environment. Okay, so now we have our data in place. So we know we want those information, and now we want to go to implement visibility. We can implement visibility with Azure Workbooks. Normally, we have here our templates available. When you implement workbooks, you can write your own workbooks, or you can use predefined workbooks. So here's a huge template list about all of your workbooks which are available. But keep in mind, workbooks are always based on the data which you have collected in your environment. So normally you can go, I will switch back to the data connectors and go to the, for example, Azure Active Directory data connector. Azure Active Directory, where is it? Here we are. So let's select the collector, open the collector page. Normally we select the data type, the log types, and here on the top, you can see here the next steps. And when we go to the next steps, we see here recommended workbooks. So we can choose here the recommended workbooks. It's really simple, and select, for example, the Zero Trust workbook. It opens the template page from the workbook. You can select here your workbook. On the right side, you can see, okay, which data types does the workbook need? So we don't have every data type in place, but it's really simple to implement. So you click on Save, select your destination, and that's it. You can use this workbook. So let's go back to our Sentinel environment and use the predefined or use the implemented workbooks in my environment. Go to my workbook, and you can see here, I have my Azure Active Directory audit logs. An important part here, this is an workbook which is coming from Microsoft, and is also updated during the time. So we can go here to view saved workbook and open the workbook based on our data and can use this workbook. You can see here, there's different views available in this workbook, and you can use it. You can for sure edit this predefined workbook. You can, for example, change here the text to another text here. Click done, or you can change the queries also. Click on save. Now it's saved in my environment. It's my customized workbooks. So that's the predefined workbook. When we come to the situation to define our own workbooks, I have here one available. Click on view save workbooks. And you can see here I have much more implemented here. So on the top, we can see here a secure score. So I've implemented based on my incident rules or my incidents okay, what's available in Azure Security, Azure Security, what's available in Azure Office Microsoft 365 Security. And here we have a summary about all of my logs based on a custom created algorithms. On the right side, you can see here Azure Security Center. This is the first thing that we can. This is the first view which is not collecting the data from our log analytics. So with that, we are asking Azure Security Center, okay, how's my security score for my subscriptions? In this case, I have here a subscription with 46.43%. And we can go here, open new link, and it will also switch to our Security Center environment and give you an overview, okay, about the status here for Azure Security Center. And you can see here we have 46% for this subscription. Another subscription I don't have permission, so I'm restricted here. Okay, then we can go down and also define our custom queries. Here we can see open incident by priority. We can see here 1 high, 5 mediums, and 3 low. But we want more information. So I can select this incident, and on the bottom you can see more details about your incident here. Or I can select a medium environment, a medium incidents, and you can see here, okay, what kind of incidents are open here. If you want to drill down into more details, you can go to Azure Log Analytics and open Azure Log Analytics with the current query. Okay, so we have to we have to think about the time. Okay, the next thing what we have to do is we have to implement analytics rules. So keep in mind you can use your built-in analytics rules, or you can also use your own analytics rules based on KQL queries. You can connect services. In this case, I have here scheduled analytics rules. Those rules are based on KQL queries. So my self-written KQL queries or based predefined KQL queries. But I also have here service connections. I have here a rule type Microsoft Security. And this is, for example, the rule of the analytics rule for Azure Active Directory identity protection. So I get here information about risky users and it. I also can use Microsoft Defender for identity, or Microsoft Defender for endpoint, and so on. Okay, let's go a little bit deeper to the rules itself. Let's open the scheduled rule here, the honey account rule. It's pretty simple. First, you have to define your name, your rule name. Next, you have to define the priority, the severity for that rule, and also the tactics. So we can choose here from different tactics, and we can choose here from different severity rules. Then we can go one step further and think about the rule, the logic itself. And here you can see this is based on KQL queries. So I'm using here my KQL queries, and here I'm also adding entity mappings. Entity mappings are really important for the next step, for the automation step. So we will see this in a few minutes. And at the end, we can go to the incident settings and say, okay, each alert will also create an incident, which we need to handle those information and also to execute in some situation an automation workbook. Or we can also send here automation task directly, or a hunting rule, a playbook, I'm sorry. Okay, then let's go to the hunting rules. So we will see more in the next demo about the analytics rules. Let's go to the hunting rules. You can use here predefined hunting rules. So you will see there are more than 100 hunting rules available, 197. But we can also use live streaming. It's also based on KQL queries. So come on, it's really slow today. You have here my live stream rule. It's checking our Azure Active Directory logs. Is there a user add to a group or to a role? And you will get an information here with the last result, and also on the upper right. Okay, there's a customer add to those rules. Okay, you can start here the live stream, and you can also open the live stream and see more here. So if something happens, the details will be shown here in your environment. Okay, really quick, really fast. The reason for that is because we have some other topics to implement. The next thing is incident handling. When we implement analytics rules normally also add an incident, a new incident. And how we can handle incident. Normally, you can see the incidents, you can do something with the incidents. You can change the alert, you can change, not the alert, you can change the severity. You can also add tags or comments for information about, okay, what you have done with the instance. Are there some recommendations for other analytics colleagues? You can also assign an incident to another colleague based on Azure Active Directory users. So you will have the ability to select each user from an Azure Active Directory and assign the incident to those users. And they will get information, okay, you have a new incident, and also see the incidents filtered by my incidents in Azure Sentinel. But you can also, you have also the ability to trigger playbooks. Normally, you can implement automation automatically triggered based on the incident, based on alerts or whatever. But you can also trigger incident. You can also trigger playbooks based on the incident manually. In some situations, it's a cool option what you have. So that's the next point: automation. Automation, or the SOA behind Azure Sentinel, is Azure Log Analytics. You using not Log Analytics, Azure Logic Apps. You're using Azure Logic App to automate things in your environment. You can choose from a big library. So we have a really huge community behind Azure Sentinel, and there are many predefined automation playbooks available to which you can use. But you can also create your own playbooks based on your needings. There are two different ways available at the moment. There are the old-fashioned way available to trigger a playbook, or there's a new way also available to trigger an automation rule for your environment. Let's see the environment. Let's see the tasks here, the live demo. We will handle incidents. We will go one step further, and I will show you the automation, and I'll also show you the playbook option what you have in Azure Sentinel. Okay, so we have here our analytics rules. Then when an analytics rules is detecting an information in your environment based on other services or based on the data inside Log Analytics, it will create, in most situations, also an incident. You can see here we have different incidents available in our environment. So we have incidents which are coming from Azure Log Analytics based on scheduled queries. That's the Azure Sentinel rules. Or we also have rules or incidents based on third-party on other services. Here, the Azure Active Directory Identity Protection, or here based on Azure Defender. So we also have connected the Azure Defender to Azure Sentinel, and then we get information about those alerts here. Okay, so let's go to the incident itself. So we can see here, for example, anonymous IP address. We will get this information from Azure Active Directory Identity Protection, how I enforce this alert. I will connect, I will open the browser connect to portalazure.com over and Tor browser, and you will see here this is the information which I get from Azure Active Directory Identity Protection, anonymous IP address login. So on the right side, you can see some information what's the product, Azure Active Directory Identity Protection. It's generated one alert, and here are my entities which are available for this alert. Let's go to more details. And here you can see much more information. So first, we can go here to the alert itself. We can see here the entities which are available for this incident. Here's the login name, here's the name itself, here's the IP address where the incident is coming from. On the right side, you can see here the comments. And it's really important. I will remove this one here. You can add here comments and give some feedback from your side, or you can also use automation tasks to add informations to your incident. So let's go to the automation itself. We have here our incident. We want to trigger, we want to check, is this IP address, is this a malicious IP address, or is a harmless IP address? So let's go to the few playbooks, and I will execute this manually. You can also execute this automatically. And I want to ask, in this case, a virus total about the IP address status. So the playbook is now triggered. Let's go back to the incident, refresh the incident. And in a few seconds, we will see, okay, a new comment. And the new comment is based on the result from virus total. And virus total say, okay, this IP address is malicious. You have a reputation of 7, and this means it's malicious. There are small information, but you get much more from virus total. But you can see here the power behind Azure Automation and Azure Logic App, and also the ability what you have to add comments. So let's go to another one. Let's go to Azure Active Directory conditional I'm sorry, not this one here. Conditional access policy changed. So we have here a manual triggered alert, so a scheduled alert. I'm sorry, not a manual triggered, a scheduled alert based on the data inside Azure Sentinel. And what we want to do is we see here, okay, what's the entities? In this case, someone have changed the name is admin@demo.acp.at, changed from this IP address the demo policy, the demo conditional access policy. It's update the policy, and I will also add some other informations to the alert about, okay, what has changed. And now I want to send this information back to the IT and validate, okay, is the change approved? Is a planned change or not a planned change? We can go here to the alerts, go to the playbooks, execute the conditional access policy changes playbook. This playbook is triggered, send an email to one or more persons, and you will get an email with the information, okay, there is something changed in your environment, there's something changed in the demo policy, and it's changed by this user. Is this a planned or not planned task? And I can click here to, for example, it's not a planned task. The Azure automation rule get those information and add those information to the comments from the incident, and you will see it here. Okay, the change was a not planned change. You have to investigate more here. So you can also use other systems like emailing or whatever. You can also post the information to Teams. There are no limitations available. So that's about playbooks. We can go in one thing here once more. We have here our playbooks, which you can use, which we have seen in the demo before. But we have also different trigger kinds. We have here triggers based on Azure Sentinel alerts, or triggers based on Azure Sentinel incidents. So this is the new way. What you can do is you can define here automation rules. And when you define automation rules and want to use playbooks, you have to use the trigger kind Azure Sentinel incident here. It's really important. And here we can do something more. We can create a new automation rule and can define here different tasks before we execute a playbook. So we have here the ability to check, okay, on which condition should we execute this playbook based on analytics rule or based on Azure Active Directory user ID or whatever. We can add, we can change the status from the incident, for example, from new to active. We can also assign automatically the incident to a user or to a group. We can also add tags here, and we can execute a playbook if we want at the end. It's really important. Okay, so that's from the live demos. I have much more samples here, but we have no time. to see all samples. Let's go back to the end from my session. So let's make a recap. First of all, what I want to say is when you want to implement Azure Sentinel, you have to use always Azure Log Analytics. Azure Log Analytics is the basic for Azure Sentinel. It's really important. Azure Sentinel is a PaaS service based on Microsoft Azure and the Azure portal. So you don't have to think about right sizing. You don't have to think about, okay, how many storage do I need and so on. It's based on pay-as-you-go, so no upfront commitment. It's required. So over the time, you have to you can implement reservations to get 50% or much more discount. It's high available and high scalable for sure. High available because it's not depending on one data center, it's on more data center, and high scalable, you can upscale and downscale automatically. It's better for investigation and to analyze security rules. So think about the options what you have with your custom rules, with the pre-built-in rules, and also you have the artificial intelligence by your side, which you can use in Azure Sentinel. And at the end, we've seen it in a short demo, we have a massive option for massive automation options here available. So you can do, I don't find any limitations here. So I have many playbooks written for my customers. So there's no limitation available, and they can also change something in Azure Active Directory. You can send an email and whatever. Okay, that's it. That's from my session. Thank you for attending my session, and now we can go to the Q&A. Thanks. If you have some question, write to the comments. So, or you can also write me an email, or can ping me over Twitter. You can see my Twitter handle here.
Rob, and you see me? Yes. Okay, so we can start. Thank you to the sponsors, and we are here today to discuss about the JSON support in SQL Server and SQL database on Azure. I'm a very active user of SQL database since the beginning, so since the first years of Azure itself. And now I can say that the SQL database evolved a lot, so much as it is more than just a relational database. It's a platform to develop stuff, to develop code, okay? And I want to share with you my approach to integrate data sources from outside in JSON format into the SQL Azure database, okay? Well, I want just to assume that this is not a fight, okay, between SQL and NoSQL, okay, with relational at one side and NoSQL alternatives at the other side. I'm using for years initiatives like Elasticsearch and either the Azure Search in production for e-commerce, okay, and I think it would be possible only with that. With a relational database, it wouldn't be possible actually, because I really think that each product, each service has its own specific scenario and specific ecosystem. So, of course, it's not so easy to maintain multiple systems unrelated, but if you need, for instance, to have an e-commerce which is really search intensive, the plain old relational database is something that can be challenging, okay, in terms of load, in terms of full text search, in terms of ratings, in terms of the concept of relevance, okay. It's not something that I can give you as assumed, okay. So I made this introduction because I don't want to pass the message that you can use SQL and relational database for everything. I just want to give you the alternative to hold a big object inside SQL, then it's performing really good, okay? Actually, I think that the integration between all the systems you have and also the word SQL and NoSQL should be the only way to achieve more and to get the good from all the building blocks that we are going to set up into our applications. Okay, let's discuss. Of course, I have a second monitor on the comments, so feel free to write the comments and the question directly in the chat, even during the session. I will very gladly read them and reply to your answer directly when you make it. Okay, so I'm really glad to be interrupted. So I missed a lot real time and in-person events when the people just can say, hello, can I ask you a question? Yes, of course. So feel free to write them and I will see it in real time. Okay. Well, this is the scenario I want to discuss with you. JSON can be a format coming from outside, from third party. In my experience, in my actual experience, we are collecting a lot of data from third parties through APIs, through other communication method protocols. Okay, but the actual payload is in JSON, so we need to store that JSON somewhere, to parse the JSON to actual store all the columns all the fields in the columns into our relational database and so on. So to be general, okay, when data from outside is coming, you should clean it. You should engineer the place that you want to put that data inside. So, for instance, a database table, multiple tables in a relationship like foreign keys, something like that. After that, you have those tables, those objects set up. You can ingest the data. And actually, you need also to perform some automated tasks to automate the software to do that automatically. periodically, okay? Just not one-shot task usually. After that, you need to put the data in a production stage. So doesn't mean necessarily that you need to perform something. When the data resides on the database, you can be okay? But you should give to the consumers, to your colleagues, to the external users, to your applications, the capability to get that data. So, for instance, you can just give them the tables, but it's not something that I can suggest to you because they would lock to that tables, and you're not so free to anymore to change them in order to refactor your data and in order to make some new features. Okay, so I would probably suggest to create a view, multiple views, to join the tables, to create what we call an aggregate. Okay, so the aggregate is something that can be useful for the consumer, the data consumer. So web page, colleague, dashboard, visualization in Power BI, something like that. Okay, good. So if no questions here, I go ahead and I show you some issues that can arise in that process. The main issue is the incoming data may change. Okay, so what does it mean? It does mean that that specific JSON with that 3 fields, okay, in an array format, after a day, a random day, should contain also unexpected entities. So not just the entity that we expect, but even another one. Okay, we can also say to the producer, hey, we had a contract, so why there is a new entity inside there? We can do this, of course, but of course we need to implement a sort of resilient systems that can ignore something that is unexpected. Okay, so this is done usually in the cleaning phase. So in that specific phase, when we read the JSON, get just the items that we expect, and filtering out the other ones. But it's not the only issue. We can have new fields. So with new fields, usually there is not a real need to. There is not a real breaking change. So if you map manually 3 columns, 3 fields from a JSON, and after a specific time, a new one arises, actually the most of the software can ignore it, and that's it. Okay, but that is the point. Do we want to ignore it or include it by default? So if we are integrating a sort of report, a sort of data set from outside, and after a certain period of time, they decide to include a new field, probably we want to include that field into the destination data set. Okay, so the parser should have something like a dynamical column creation in the database, something like that. Because if you have fixed columns into the database and a new field is coming from the JSON, you would probably need to create a new field, a new column to hold that stuff. And how's about the data format? And how's about the collision with other columns or collision with the underlying constraints of the database? If, for instance, we have 100 new columns and we are hitting the limit of the underlying table, I don't know why, but I'm just assuming, okay? It could be a problem, okay? We can also have indexing problem. So if you index the table with a fine-tuning strategy to some fields with an include approach, or you just thought about the clustered index with a composition of columns or something like that, new columns can interfere with that. Okay. Finally, we can have missing columns, and in case of missing columns that up to now we always had, how's about it? So if you thought of those 5 columns as mandatory, and in a given period of time one of them is null, how to go ahead? You wouldn't, probably, because your database has been designed with that columns not null, for instance. So you can always go to the producer and ask why that column is null, but of course, in the meantime, you're losing that and you're losing time, okay? And you need to perform the cleaning step again, engineering part again, and so on. Good. So let's present the real scenario and the demonstration scenario. We have two JSON datasets. One is movies dataset, like, I don't know, like 10,000 movies. And one is the reviews of that movies, okay, with a spoiler alert, something like that, okay. It's not something that I made by myself. It's something that I took from Kaggle. I took randomly, so it's not a matter of the semantic of the data, just for the demonstration purposes, okay. I want to produce a consolidated view. So join movies with the reviews, something like that. So let's present the data. So here, okay, this is the data set, two files, movie details and reviews. Reviews is quite big, okay, it's not huge, but it's quite big. This is the structure, so review date in a string format, net text, plain text format, movie ID, user ID, is spoiler, review text, and rating and review summary. Okay, we can also visualize it through a tool that I found very, very useful that is called Deadwrite. So why is really useful? Because it threads huge JSON files like this one gigabyte file in few seconds because of the underlying technology. So I really suggest to use this for your work. So this is the dataset I'm going to discuss right now, and let me just go ahead. Okay, with the engineering part. Okay, so we have now the data. We need to create the tables that will hold that kind of data, and I want to show you a couple of issues that I can find in this process. Okay, as a general advice, I would like to sponsor the usage of database projects. Database projects are an artifact from Visual Studio that could contain all the objects about SQL in a project, in a Visual Studio project. This is very useful because you can hold the tables, the views, the sort procedure, and every single object in a specific single file. And the build process will build all the stuff together. As we see, we are highlighting an error. So it's highlighting that there's no this column name into the movies table. So it's something that can help us to build consistent databases and also version the files into the Git. Okay, so I want to highlight something that for me sounds really weird. Okay, the movies table is okay. We needed, of course, to make some assumption of the rating. Okay, the rating should be something between 0 and 10, so probably 10.0 or something point, a single decimal. So I would say decimal 3.1, but I don't know. Okay, so it's just an assumption. Reviews is something that holds some weird things. This is the first. There is no review ID in my original dataset, but I would like to have one to create also a clustered index on this in SQL Server. So I don't want a heap, and I want to introduce a review ID that's just in the identity. So it's a surrogate key. So it's something that does not exist in the domain. Okay. The second thing is that one, the foreign key from the movie ID to the movies data, the movies table. It makes sense, but I discovered in the dataset themselves that some reviews as a reference to a movie idea that didn't exist in the movies dataset. Okay, so this could be the problem before. So why there's a review with a orphan movie? Okay, I don't know, but with this relational approach, we could not import a review that has not the corresponding movie into the movies table. Okay, so this is the second constraint, in my opinion. Good. So let's come back here. And now let's think about the third point, the ingestion part. So some process that can take the incoming JSON and transform it into relational tables, into the contents of the relational tables. Well, I suggest in production something really enterprise, like SQL Server integration services, Azure Data Factory, other data movement tools that can help during this phase. But give me a second, I think Rashana has a microphone on. Okay, and I think that in this case, for this demonstration,
Stop. You continue. Just I'll go on mute.
okay. In this presentation is too hard to demonstrate an integration with a real-world enterprise tool, so I preferred to leave you an implementation with C# with all the importing logic. Okay, so I just read the big JSON, and for each review I created an entity framework entity and add all the stuff into the database through entity framework. It's not something that I would suggest because it's not really performant, but it's just for demonstration purposes and just because it's on Git, so you can easily use this at home. Okay. Good. And after that, we have the database here. So with the plain old relational table movies, reviews, and what we want to do right now is to create the aggregate. So we can create a view that is movie plus reviews. We can say movie ID, all the stuff here, okay, and not the review ID. I don't need this. I don't need also movie ID because it's already here. I can take everything. The rating is twice here and here, so I can call it review rating. Okay. And now I can save the review. And this is the aggregate I want. So with all the types is quite trivial. Okay, it's trivial because it's just a view of a join between two tables. Okay, good. So we saw the ingestion part and the production part. And now we are at a corner. Okay, we can decide to keep the tables, the relational tables, or to avoid the tables and proceed in a JSON approach, in a text approach. Okay, without any logic of parsing and any logic of stronger typing into the database table. We should keep the tables when we need to edit the individual rows, for instance. So if we want for that review to change just the rating, to fix with an update the rating, we should keep the tables. Why? Because if we have a JSON with all the reviews and we want just to edit a single one, we need to read all the JSON, change that field, and re-upload the JSON into the field. Okay, we are thinking about a solution where JSON is inside a single cell, so a single row and column there. When you need to perform aggregation, so when you have the JSON, a big JSON with some useful insights of data, and you want to perform aggregation, probably it's better to keep the tables, because otherwise we should scan a lot of data, useless data, to find just the data that we want to aggregate. But if you are not under these circumstances, and you, for instance, have data, immutable data, for instance, a review is immutable at 99%. So there's really a small chance that a review, not really a product review that can be re-reviewed, okay, but we are reviewing a movie, okay, it's like that, okay. The movie itself, it's immutable data, so the movie title doesn't change, never. Well, I wouldn't shoot that, but 99.99% it doesn't change. So in case of immutable, the weather, okay, the weather was yesterday. So the weather outside, I'm in Milan, the weather of Milan of yesterday, it's not changing tomorrow, okay? It's an immutable data. So when you have an immutable data, you can use actually something like JSON into your database, okay? Also, and here is the point that we discussed before with the limits of the architecture, when you have a data that can change, incoming data that can change there, it's really better to have JSON, because the JSON itself inside a single cell of the database may have different structure between it and the previous one, and also new columns, new fields, missing fields, different types, and everything is database consistent. And we are looking into how to get the data from that in the next demonstration. So now, if you have any question, feel free to comment it in the chat. So now we have, let's take the first row. I have a table that is called movies hybrid. Not because of a common terminology. It's not something. It's something just I introduced to say that in this case we have some plain fields with a specific type, strong type, and a field containing all the JSON array of the reviews of that movies. Okay, but if we can go that way, we can also go that way, where all the relevant stuff is on the table itself. Okay, so the movie and the movie details and the review details. Okay, so in this case I would say full, because everything about this line is into the single row. Just a second. Sorry about that. Okay. Well, now let's introduce the JSON function. Okay, so let's would say not the top one, but another way to limit a single row. So where the movie ID is like this. Perfect. So let's say star, but also JSON value from the movie column, and take the JSON path plot summary as a summary. Okay. So SQL took out from this root document the specific property. Okay. After that, we can go straight ahead with, let me take movie details. So duration, genre, rating, release date, plot synopsis. Okay. So duration, genre, rating, release date, and plot synopsis. Okay. Let's perform a little bit of copy paste business. Okay. And we are quite okay. I don't know why plot synopsis not here. Okay, because it's null. It's empty, so it's okay. But genre is null. Why? Because genre is itself a JSON. Okay, it's not string. It's not something that can be valuable into a columns. But there is a way to say to the engine, well, in case of JSON, keep just the JSON representation, and it's the JSON query function. So we now have all the stuff. So we can avoid to keep the movie part again. So we can just take the movie ID and the reviews and that stuff. Okay, good. So now let's work on this reviews part. Let's put for a minute those values. That is the movie part. Okay. The reviews part is something that it's a little bit different because this is an array. So we need to say, hey, cross-apply the single row to the open JSON that converts, not really converts, that usually creates, open the JSON array and apply each item of the array into the single row. So in this case, I can open the reviews array like this. Let's take the value part. And I have one line for each reviews item. Okay, good. So now we can proceed as we made before. So in this case, excuse me, you have the microphone open. And now we can go ahead with the parsing. So review date, movie ID is not needed anymore. User ID is spoiler. Okay. Review date. User ID is spoiler. Review text rating. Text rating and review summary. Good. We can take this off and let's perform a little bit again of copy paste. This rating should be duplicate here, so I can call it review rating. And this is what we need. Okay. So we also explain that, and if we uncomment this part, we have pretty much everything. It's not really in the same form as the original, as this view, okay? Because for instance, this duration is not a time, just a text. The release date is not a date. It's text. Either this review date, it's another. It is in another format. This is spoiler is just the string true, not the bit 1, 0, and so on. Okay, so we can perform a sort of conversion. So we can say try cast this rating as decimal 31. Now this is strong typed. Release date the same. Try cast. This is as date. And this as date 2. This as bit. This as decimal. And that's quite okay. Except from this one. This should be treated in a more creative way. So for instance, I can replace the H and the space with a column, the min with a column, then 0, 0, and after that I have a time span format, then I can cast to a time. Okay. To do that, I can perform here the replace, 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 but I preferred to introduce a function that is called as time span. Let's take a look at that function. And we can use it here. And we are okay. So now we can take out the where condition, make some cleaning, and create view dbo view 2 as let's take a look at the view, and it's quite the same. Strong typed. The actual difference are the nvarchar for 1000 instead of the specific nvarchar, well, max that I created into the original tables, but everything else it's okay. The bit, the time, the date, the decimal, and of course the result, it's feature equivalent. Well, the ordering is not the same because while I created the view from the designer, I made some mistakes, but it doesn't matter. So the actual result for the consumer perspective, it's the same. So what we learn from this approach, the JSON value function takes out a value from a JSON node. The JSON query takes the node in the original raw JSON format, like the January array. Is JSON, we didn't see that, but it can be used like a constraint. For instance, create table with these fields, and the JSON column is just a varchar, okay, or an nvarchar, with a check constraint to check if the actual content is JSON. So it's the only way to have a JSON check into a common field into SQL Server. We are probably waiting for the native JSON support with the JSON column type, but for the time being, we're just using text, okay, the varchar. And OpenJSON at last is the way to open the array into individual rows that can be applied to the specific row that are you using. Okay. So now let's introduce some provocatory concepts. Okay, we can have whoa. Okay. 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 And you here again. We can have a table that is called playground. So let's select all the ID from playground key value. Okay, it's a table with just 2 lines. Okay, why I didn't take the star? Because in the other field, the value field, the doc field, there's the entire JSON of 14 megabytes in case of the movies one, and almost 1 gigabyte for the reviews one. in a single row, in a single cell. Okay, it's supported, but of course it's quite huge, and we can do this with some constraints. Okay, if we need to scan just individual rows, we can do this. If we need to perform complex operation between different rows or with joins to external tables or with aggregates, it's not really recommended. So what is not recommended, for instance? This approach. And this approach, the view is taking the row number 4, which is the reviews object, applying each document as a subquery to then join that to the movies took from the row 3. Okay, so the query plan is like take all the stuff in memory and then join the stuff and produce the result. Really, really heavy for the processor and not recommended at all. But we can do this. Okay, so this is provocatory just to say we can have definitely tables with a key value mechanism like a key value store, and then use them generally into the remaining tables, be referenced with the foreign key to all the attachment parts of different kind of objects. Okay, good. So at last, I want to give you some takeaways for the future. If the data does not change anymore after some point and the JSON becomes huge because, for instance, you continue to collect rows, or you need to perform some analysis, you probably want to make historical tables on that row data that you collected into JSON format. So what is my suggested approach is to denormalize it and store it into proper structures. Okay, well, the denormalization part actually is just performed with this view that creates the aggregate. Okay, but as you probably know, we can say, hey, select all the stuff into a new table. And of course, this new table is not JSON. It's the table resulting from this view, so it's strong typed. It has no clustered index, so we can define it a heap. But it's very easy to scan, and the performance of scanning is quite good. Okay. Let me recreate it with some more rows. So like 10,000, just to see the impact of the database in terms of space, in terms of size. Okay, we have 69 megabytes for 10,000 of rows. Okay, in the normal one, so only the reviews is like that, only the movies is like that, and the full JSON approach, we have 1.5 gigabytes almost for these rows. Good. What I want to suggest to you is that after you don't need to process that data in this live JSON format, you can make historical tables like this and then compress it through a column store technology. So we can say create clustered index. The name on this table, and also column store. What is the column store index? It's a way to, it's not like an index or a standard index taking just one of a combination of fields to perform better queries. It's something that recreates the tables in a column store format, so in columns instead of rows. So when SQL Server converts that table in that format, all the rows of a specific, well, all the values of a specific columns are grouped together and then compressed. So after that, we see that from the 69 megabytes of the original table, a compression that keep the sites to 9. But it's not the only way that why we use that approach, because we can also use page compression, group compression, in the field. What we can do also is aggregates operation. So after that, we have a table that since it's organized by rows, let's take 10 rows from that. We can have the average of the rating, for instance. Okay. In a fraction of seconds, okay? And you can say, okay, well, of course, it's 10,000 rows, okay, but I have the full table here. So I can do the same to the denormalization review CCI that is containing all the stuff. And the results, it's quite seamless and in a fraction of seconds. Why? Because since the column, this table is organized in columns, the actual aggregate operation is really faster compared to a row-based table. Okay, so this is something that you can experience as just a final approach to your data that can be freezed as historical data, or even for every other scopes that needs this kind of compression and grouping functions. So as a takeaways, I really love relational database, but I really understand that it can be coexist also with JSON inside the database, but also outside. If you are thinking about the data lake, of course, you can avoid to use the relational database at all. I would suggest the normalization for long-term storage, and I didn't show to you, but we can also apply indexes through into the JSON columns to perform better fetching of the data. Okay. In EF Core, we don't have native support to JSON, so we need to take out the text columns and perform our logic. But since it's already existing in this Postgre implementation, the deserialization is up to Postgre and the Entity Framework provider. I would expect that in the next version of Entity Framework 6, Core 6, we could have to that kind of approach, that kind of support. So I thank you very much for being here. I'm here to reply to your questions. Those are the takeaways that I discussed in this session, and I really hope you like it. And thanks to the sponsor. If you have some questions, I'm here for that.
Thanks, Rob. It was a very nice and informative session. And let's wait for some questions.
Yeah, thank you.
I don't think we have any questions, Rob.
Okay, thank you very much. And in case, I'm here for some other minutes to get your questions in the comment. Otherwise, thank you very much and have a good conference. Bye-bye.
Thank you. And audience, if you have any questions, please send it to Rob. And also, I'll post a feedback link for this. Please submit your feedback. Thanks.
Yes, thank you.
Welcome back after break. We are ready for the next session. How to build a AI-based chatbot using Azure Q&A Maker. Our speaker is Mr. Namish Bansal. He's a 7th grade student, and I really appreciate his enthusiasm of presenting in this big event. I welcome Mr. Ms. Bansal.
Okay, hello everybody. My name is Namish Bansal, and this is my session on how to build a chatbot using Microsoft Azure. So let's get started. So, okay, hello everybody. My name is Namish Bansal, and so I'm going to share my screen.
Yes, Namish, please share your screen.
Okay, so how to build a chatbot, an AI-based chatbot using Q&A Maker with completely free resources by Namish Bansal. So a little bit introduction about me. I'm in 7th class. I am 12 years old. I am currently living in Delaware, USA. I recently got into Azure and AI and did a couple of certifications such as AZ900, AI900, TP200, and TP201. And I made a chatbot for my school. You can check it out at myschoolchatbot.com. And my channel name is SuperFlameNB, where I also post more tech videos and more like chatbot videos and like how to do that. So, what is a chatbot? So, a chatbot is a computer program designed to stimulate a conversation with users. And some chatbots include conversational AI, but other chatbots are limited to using the text in the knowledge base. What this means is every chatbot has a knowledge base which it extracts information from, but some chatbots are smart and they have the ability to try to understand what the user is saying, as in like a conversation. Like it can understand what the user is trying to say. Like so, let's say if the user misspells a word or says it in kind of different phrase, the chatbot will still understand what the user is trying to say if it has conversational AI. And so our chatbot will have conversational AI. So these are the steps, these are the basic steps that we're going to use to make our chatbot. So first we're going to make the Q&A maker with NLP. And then we're going to insert knowledge using FAQs and manually. And then we're going to make the web app bot. And then we're going to make the website to host it on. And so this is just the general architecture of the chatbot here. And these are all the things that we'll be talking about today. And as we go along, I'll go through these things one by one. So let's get started. So we're going to open up the Azure portal. So azure.portal.com, portal.azure.com. And then we're going to sign in. So this is the Azure portal. There are different resources here where you can like select different resources. Like there are different widgets here. There are different Azure services here based on what you generally use. And there are different resources here. And then there's a search bar where you can search all these things up. So we're going to go to the search bar. And I hope you're following along with this. Like if you or you can always come back to it. But I hope like this is like something where you can like follow along and try to do the thing, make the chatbot with me. So let's go to this. Let's type Q&A maker in this search bar, and under marketplace, we're going to see a blue bag with a cloud on it, and then next to it says Q&A maker. So we're going to click on Q&A maker, and then we're going to get started with creating it. So select your subscription, select your resource group. We're going to see down, and then a name. And then select the pricing tier. So I said this was completely for free, and it is, but one of the downsides is you can only create one free chatbot per subscription. So I already created my free chatbot per subscription. So I'm going to select the standard tier, which has higher performance. But for learning purposes, I would suggest selecting the free tier. And same with Azure Search. Azure Search, like these tiers have higher and higher and higher performance. But the free one is also just good also for learning purposes. And so I'll also create an app service and app insights. It's not a necessary thing to install, but I would recommend it because it does provide some useful information. Now we're going to, if you want to add some tags, you can add that here. And then now we're going to create it. So as it's creating, let's go back into the architecture. So what did we create here? So we created a Q&A maker here, but we also created a language understanding, meaning this Q&A maker is what makes the chatbot smart. Like the smartness of the chatbot comes from Q&A maker. So like the ability to understand what the user is trying to say. And the Q&A maker will connect to a knowledge base, and the knowledge base will have the questions and answers provided for the Q&A maker to run. So let's go back. It's still deploying. Takes about a minute or so. So your deployment is complete. And now we're going to click on go to resource. If you want to check deployment details, you can just click on here and it will show you all the information. But we're going to click on go to resource. Now there's one very important step that you have to take if you want to make your chatbot free. So what you need to do, you need to go to your resource group. Because one of the services makes the plan default as paid. So we need to change that setting to free. So we're going to go to this app service plan here and click on that. And then we're going to click on scale up under settings. And then you can always use these standard ones if you want to make it like a production workload, if you want to do a much higher performance. But for like just learning purposes, I suggest the free one because it also has some good performance. It gives you 1 GB of memory and 60 minutes compute. So click on apply. And so what we're going to do is we're going to go back. And then we're going to go back into our Q&A maker here. And so now we're going to go get started with making the knowledge base. So next to this number 2, it says navigate to the Q&A maker portal and begin creating knowledge bases. Under that, there's a link for Q&A maker portal. We want to click on that. And it's going to take a little while to load. And so it's create a Q&A service in Microsoft Azure. So we are going to, so if you go straight to this website, you can create a Q&A service from here. But we already created it, so this got linked to this Q&A service. Our Q&A service that we just created is getting linked to this knowledge base. So we don't need to do this stuff. So it already updates Monday Free 2020 Outlook is our default directory. Sometimes it doesn't select the right one, so you need to go back and select it. Select your subscription name. Select the service that you made. And while this is creating, I just wanted to mention that this here is the knowledge part of our architecture here. So like this is like where the data sources is. This is the knowledge part. This is where we're getting this is where the chatbot is getting the knowledge from in order to project that knowledge inside a chatbot. This is where the knowledge is coming from. So it's loading its language settings. Okay, then we're going to select the language. So we're going to select whatever language you want. I'll click on English. And so we're going to name our KB. So and then we're going to populate our KB with FAQ. So we can, so any FAQ you throw at this, like any FAQ you add into this, it will extract all the questions and answers that are there from there. So we're going to go to a COVID FAQ, and it's going to extract questions from that. And you're going to extract questions from any FAQ you want, and you don't even need to have an FAQ. FAQ is an optional step, because like if you just want to manually add information, that's allowed too. But we're going to go to a COVID FAQ by CDC. So we're on this page. They have all the information like what is COVID-19, how does the virus spread, blah blah blah. So we're just going to, all we need to do is take the link and copy it into our Q&A maker here where it says URL. And so you can also add a file with like a CSV and a TSV E format here. And then there's chit chat. So you can like in like regular conversation, there are lots of different questions. And Microsoft made a list of all the questions. And it's like just regular question like hello, how was your day going? What's your favorite type of food? All those regular questions. Microsoft already made a database out of them. And he made different ways you can answer. So click on this learn more about chit chat. There are different ways you can answer a question. Like age isn't really a professional personality. Like if it says when is your birthday, a professional personality will say age doesn't really apply to me. A friendly personality will say I don't really have an age. And like there are different kinds of personalities which can be used for Q&A maker. So I'm going to select on a friendly one for this demo purposes. And so I'm going to create my KB. And so this will have both the chit chat database loaded and the COVID FAQ database loaded. And you can also add more of your own pairs. You can add more of your own questions, and you can edit the questions that they already added. So the knowledge base is loaded. Should load it. Okay. So it's fully loaded. So if somebody asks the question, what is COVID-19? Then it will give an explanation. COVID-19 is a disease caused by a virus called SARS-CoV-2, blah, blah, blah. So we're going to click on test just to test it out. So we're going to have a little conversation with it. So we're just going to say hi. And so it's going to respond to us back. So we can just keep on talking like this, like how is your day going? Great, thanks for asking. And then what is COVID-19? And then we'll give an explanation. And now the smart thing about this, even if we misspell something, then it will still understand what we're trying to say. So we type how does COVID-19 spread? And it still gives the right answer, even though the question here, as you can see, was how does the virus spread? But it was still able to understand what we meant. That's where the smartness comes in. It was still able to understand that this COVID-19 thing is attached to the virus. If you click on inspect, we can see how much confidence it had. So it had a 63% confidence that this was the right answer. And like for other answers, it had like a 46% confidence and a 29% confidence. So we're going to keep it as this answer. And so we can even misspell a word like how does the virus spread? And it still gives the same thing, even though I misspelled virus. So we'll still be able to understand. And see, it has a 99 confidence score. Even though I misspelled something, I was still able to very clearly understand what I was trying to say. So now let's try adding our own thing here. So, let's just type something like who designed you? Amazing, what? So, then we're just going to type something on frontend console. and then we're going to save it. So this, going back to our PowerPoint here, this is like the text input. This is where the input is coming from. The input is coming from typing, and it will also come from clickable cards, which we'll get into it in just a minute. So now it's saved. We'll see when this thing is white, and now we're going to test it. So we're going to have some. We're just going to test it. Who you amazing bot. Not sure. So if even if we mistype something, it still understands it. So now let's go into clickable cards. So now let's add it. Now let's click on add follow-up prompt. So it's saying who designed your amazing bot, and it's saying Namish Bansal, but it's not giving any information about me. So we should make it so that if they click on a button like learn more, then it will give information. So we're going to do display text for the button to be learn more, and then we're going to create a new Q&A. So we're just going to click on save, or we need to create a new Q&A here. So Namish Bansal. Bansal is a 12-year-old boy creating a chatbot. We can make this bigger if we want, but this is just for demo purposes. And then we'll save it, and then we'll save this. And we can just keep on adding, removing questions like from this, and we can keep on manufacturing it until we're satisfied with it. So let's just type who designed your amazing bot. And then so when we click on learn more, this Namish Bansal is a 12-year-old boy creating a chatbot. So we can keep on editing this as much as we want, make it as good as we want. But when we're finished, we're going to go click on publish. And then we're going to click on publish here. You can always go back and edit it later. But once you're ready to release it to the world, you should publish it for the first time. So now we're going to click on create bot. And so this is the bot name, the subscription, resource group, location, pricing tier. We're going to select the free one. You can select the standard one if you want. Chatbot, SDK language, Q&A authentication key. Make sure it's the same one that's here. Sometimes it doesn't copy. So if it doesn't copy, then just copy it from here. It's like actually this endpoint key thing here. Don't include endpoint key. And where app service plan, application insights, you can turn it on if you want. It gives some information, I think. And then Microsoft App ID and password. So click on create. So while it's creating, I just want to let you know, this is the bot thing. This is what's linking all of it together. This is what's linking the input to the channel and the device. They're all linked together, and this is what's linking it together. So this all is being linked together through this bot service, and the bot service is getting the information from our knowledge base that we created. So while this bot is being created, I just wanted to talk to you about what this where we're going to host this. So we're going to host this on a site in this demo. We're going to use Google Sites for this demo, but you can create a site based on HTML or Wix or anything like that. Basically, what will happen is this bot will give you some HTML code and with some authentication key, and you just need to put that into whatever software you're using, and it's going to be working. So we're going to click on go to resource. We're going to go to channels. I tend to use this old version, but you can always use the new version. I think it's the same thing. And so you can see there are so many different ways you can connect your bot to the world. You can connect it via Alexa, Teams, Facebook, Line, Slack, Skype. So many different options are there. Email, telephone. There are so many different options. But we're just going to create it based on the web. So we're going to click on Get Bot Embed Codes. Click here to open the web chat configuration page. And this is the channel. These are all the channels, and we're linking this to the bot service as well. And the device also is getting linked to the bot service as well. These are all the different devices. There are IoT devices and like gaming consoles and all that you can use. I'm not just going to use like plain phones and laptops, and we're just going to connect those using bot service and get the data from this knowledge base and the Q&A maker from the language understanding from Q&A maker, and we can even connect APIs and all that to our chatbot using bot framework. And so here we are. So don't show anybody your secret keys because they can access your chatbot through it. So I'm going to show you because I'm going to delete this chatbot after I finish this session. But don't show anybody this key. So I'm going to show it here, and then click on copy. And then you're going to go to Google site. So just type sites.google.com and then create a blank site. And then you can design the site as much as you want. I'm going to make it very simple just for learning purposes. AC conference. And then AC conference demo. And then we're going to embed our code here. And then we're going to copy and paste the secret key from here into this. And we are going to click on next. And we're going to click on insert. So you can even do this with like your own site with your own HTML. So we're going to click on publish and publish it. And so then we're going to view our published site. Hello and welcome. So we're going to have a little conversation with it. So hi, just for testing. Hi, how are you? I know you're trying to asking, but so what is COVID-19? And wow, you really know your stuff. So it gives a joke because it knows like we want some more stuff. So then we're just going to say either who designed you amazing in bot, and who is this non-responsive person? Oh, okay. So then this is working, and we can add more knowledge into this. So like we can like, let's say we want to add a question. What can you do? Want to add a question? What can you do? I can tell info about COVID and have a conversation with you. And then we're going to save it. And then we don't even need to refresh the page because it's so much interlinked that we don't even need to refresh the page. So we can just type, what can you do? So sometimes, so this is the Q&A maker question, but we also need to publish this again sometimes. Oh, we need to publish the bot. Yeah, that was that. So we need to publish the bot. Yeah, so we should always need to publish the bot again so that it's linked. So we won't just do like that. We need to publish it so that the information is saved. And then, so now when we ask the question, what can you do? Not even saving it or anything. Like I can tell information about COVID and have a conversation with you. So we created a chatbot. Yay! So a couple other things you can do with this. You can customize the bot, make it look cooler. So we can just type bot customization Azure. And the first link that comes up, web chat customization in the bot framework SDK. We click on that. It gives a brief guide as to how to customize it. So you can just add a background color. We can change the font of bubble. We can change the font of the text and change the bubble color. We can add avatars, and we can add like a cool avatar, like a person avatar and a bot avatar. You're just using some code. So to learn more about it, you can just check this. And there is also, you can type application insights Q&A logging. And the first article that comes up, get analytics on your knowledge base. You can click on that, and so this is go to application insights resource, and then we can just run the query here, and then total traffic. We can just show, they will just show what the user is asking. So these are just the code stamps for that, and so then we are done. So for more chatbot videos like this, and basically another guide on how to do the same thing, if you ever want to refresh, you can check my channel out, Superflame NB. So you can just check that here. And so this is the technology stuff. Like I have a technology video, like how to create a chatbot with API integration, how to host a website with Azure. I have lots of technology videos, sometimes about Python as well. So we are done. So does anybody have any questions? So if nobody does anybody have any questions?
Thanks, Namis. I will wait some time for questions. We
Okay.
have 4 more minutes for the next session.
Yeah. Okay.
Thanks for the next session, Namis. It's so informative. Also, we learned about how to create a chatbot. It's
Okay.
really impressive that you have done this Azure certification and other stuff, and also creating the chatbots.
Yeah, and also we can if you ever want to contact me with any questions, my email is numishemail@gmail.com. Just numishemail@gmail.com. So you can just see my social media here. If you ever need to contact me. So right here. So my channel is Superflame NB. My email is numishemail@gmail.com. My LinkedIn is Namish Bansal, and my Discord is registered here, Numish15 #3462. So if you ever want to contact me, then you can just do it here with questions. So thank you very much for listening to my session. So if you ever want more information, then just contact me there. And thank you very much for listening. So I'll just leave this there so that you can see it.
Thanks, Namis.
Okay. Yeah.
Okay. Now we have next session, Azure Fundamentals 101. I would like to our speaker Deepthi Gauri. Um, Let me have it into the stream. Hi Deepthi,
Hi,
sorry
how are
was.
you?
I'm good. How are you?
Sure, doing good. So can I go ahead and share my screen?
Yes, please.
Sure. Um, just let me know if you can see my presentation.
Yes, I have added into the stream. It's all yours.
And you are able to see in the presentation mode, right?
Yes.
Awesome. So thank you so much, Rajesh, for moderating this session. Thank you so much, everyone, for taking your time for attending Azure Community Conference, especially related to Azure community. So, thank you so much for giving me this opportunity in the first place to speak at this huge conference from India. Thanks to all of our sponsors sponsoring for this event. Without your support, this event would not have been possible. Myself, I am Deepthi Goguri. I'm a SQL Server database administrator and a Microsoft certified trainer and Microsoft certified solution expert. I did my master's in computer technology at Eastern Illinois University, and I do blog for dbanuggets.com. And if you would like to contact me later, at dbanuggets is my user ID for the Twitter. It would be an honor to get in touch with you later. So we are talking about Azure Fundamentals 101. This particular session is a basic Azure Fundamental session. If you're not familiar to Azure, and if you wanted to go ahead and start your journey with Azure, you can start from here, because by the end of the session, at the last slide, I'm going to provide you all the resources that you need to go ahead and start your Azure journey. And there is one a special thing as well over there where you can go ahead and take your certifications for free. So hold on for the last slide to know it. So as an overview, we are going to complete this session very quickly in 30 minutes. So we are going to see an overview of the deployment options we have, and then the purchase purchase options, the purchasing models that we have, because anything you touch in Azure, there is a cost associated with it. So we are going to talk about the service tiers, compute tiers, purchasing models, and then we are going to create our first Azure SQL database. And also in the last slide, I'm going to provide you the resources. So there are three deployment options. Like there are mainly two ways that we can deploy. It is infrastructure as a service as well as platform as a service. Under the infrastructure as a service, we have SQL Server on Azure VM. And under the platform as a service, we have SQL Managed Instance and Azure SQL Database. So let's go ahead and dive deep into each one of these deployment options. The first one, which is SQL Server on Azure VM, is the infrastructure as a service. So it is basically the same exact thing as SQL Server on-prem, but if you host your own VM, right, it is a similar thing if you put your SQL Server on Azure VM. But the only difference is our virtual machine is hosted on the Azure infrastructure. And the main difference is if you have older versions of SQL Server on-prem, like for example SQL Server 2008, your older versions of SQL Server are not supported anymore in the Microsoft from the Microsoft. But if you move your SQL Server onto Azure Virtual Machine, even though if you are on older versions of SQL Server, you get that extended security updates and patches on your when you are on Azure VM. And also, similar to the SQL Server on-prem, you still can access the operating system as well as you can access and control your SQL Server instance as well. And you can deploy SQL Server on Azure VM in two ways. You can manually go ahead and install Azure Virtual Machine and install SQL Server on the top of it, but you can do that automatically by using the images. So, what are these images? Images are the pre-installed packages of Azure Virtual Machine version as well as SQL Server version. So, they have different combinations of these versions of operating system and the SQL Server. You can just go ahead and click which image you would like to install. And with a single click, you can go ahead and install Azure VM. And by the time you open Azure VM, you have SQL Server installed automatically. And by using the Azure images, right, you'll get that automated extension, IAS extension, which is basically a free extension on Azure, which will unlock certain features while managing your servers on Azure. Let's talk a little bit about SQL Managed Instance and how it differs from SQL Server on Azure VM. SQL Managed Instance and Azure SQL Database comes under the platform as a service. So, uh, if you wanted to move, lift and shift your environments, on-prem environments to the Azure, and if you do not want to make any changes from the application side, and if your future plan is going to Azure SQL DB, or if you still want to stay on Azure as an instance, then SQL Managed Instance is right for you because all you don't get is the opportunity to access and control the operating system. Microsoft is going to take care of the operating system for you, but you still have the ability and the control over your managed instance, the SQL managed instance. You still have the SQL agent, DB mail, linked services, service broker, etc. But if you wanted to go ahead and look into the file system, drives, you will not have that ability. When it comes to the Azure SQL database, if you are deploying a new cloud application and all you wanted is a database and not the entire instance and or the operating system, Azure SQL database is right for you. Because by the name itself, all we get is a database and we do not get an operating system or an instance. So this is especially for the single databases and this is used for the modern cloud applications. So let's do some of the main comparisons between the Azure SQL database and Azure SQL Managed Instance. The change data capture is not available in Azure SQL database, but is there in Managed Instance. Common language runtime is not there in Azure SQL database, but it's there in Managed Instance. Cross database three-part name queries, like for example, the database name dot schema name dot table name You cannot do that by using Azure SQL database. And cross database transactions you cannot do. But to solve that problem, we have elastic queries. Database mail, as you get only the database, you will not have database mail, resource governor. But especially for the Azure SQL database, right, you will have that automatic tuning of your indexes, where it will go ahead and scan the indexes which are not being used, and you can look into the report and then go ahead and apply to drop or to create those indexes which are missing, or unused indexes where you can go ahead and drop. And SQL Server agent, right? SQL Server agent is not there in Azure SQL database. And by the way, automatic tuning is only available in Azure SQL database and not for the Azure SQL managed instance. So let's talk about the purchasing models. Now, why purchasing models is so important for us to know? Because any service that we touch in Azure have cost associated with it. And as a DBA, if you wanted to migrate your servers, on-prem servers to Azure, you are the one who are responsible to let the company know how much it might cost for them to move to Azure. So there are two main purchasing models here. The older purchasing model is a DTU model, which is known as database transaction unit, where all the resources combined together comes under DTU, like compute as well as the storage. Now, what is this compute? Compute comes the memory, CPU, as well as the storage, IO. Everything, all of these resources combined together, you cannot separate them under the DTU. So one DTU is approximately one transaction per a second from based upon the Microsoft. So this is the older model, not recommended by Microsoft anymore. But vCore model is the recommended model from Microsoft, because here you have the ability to choose and separate the compute as well as the storage. So we have three different models under the vCore model, which is general purpose, hyperscale, and business critical, which where we are mainly focusing on in this session today. So we are going to see in depth of what are the differences between each of them and what are they in the next slide. But if you are using vCore model, you have this Azure hybrid benefit, where if you have the on-prem SQL Server licenses, and if you wanted to move to Azure quickly, you can trade off those on-prem licenses for Azure and get up till 40% of discounts. And then the reserved capacity. Reserved capacity meaning if you can reserve the resources that you wanted to use for the next upcoming 3 years, then you'll get a benefit as well, the discount as well. And if you wanted to move your on-prem servers to SQL managed instance, the only option you have to choose is only the vCore model. You cannot choose DTO model for the SQL managed instance. Now let's talk about the service tiers. Under the service tiers, under the vCore model, we have three different tiers: general purpose, business critical, and hyperscale. So let's talk about the general purpose for a minute. General purpose, as the name itself says, is for the general businesses. It is the lowest budget model, and all you get is only one primary. You will not get any readily available secondaries. But if you wanted to do the failover, right, it will take a couple of minutes to build that readily available the secondary. But all you get is a primary. And under the general purpose, you have two more compute tiers, which is provision and serverless. So we are going to see that provision and serverless and what are the differences, what are they in the next slide. And general purpose can handle up till 80 vCores, and it can handle up till 4 terabyte of database. When comes to the business critical, right? The next tier, it is for the critical businesses where you cannot go down, and the always on is inbuilt. You get that readable secondaries, two readable secondaries available. And if you have in memory OLTP on prem servers, the only option that you can choose in the general purpose is business critical, because it is especially for the in memory OLTP. And it is low latency when compared with the general purpose, but high cost, because now you are getting the readable secondaries readily available and additional features with it. The cost also increases. and it can handle until 128 vcores and handle 4 terabytes of data. But if your database is growing, right, more than 4 terabytes, you can go to the hyperscale. Hyperscale is especially for the single Azure SQL database. It can handle up till 100 terabytes of space, and it can do point in time restores. They have a built-in algorithm where they store the data at different layers of the cache so that they can do point in time restores very quick with low downtime. The SLA, the service level agreement here is 99.995%, which is like very less downtime. So it can handle up till 4 readable replicas and up till 80 vcores. Let's talk about the compute tiers. These two compute tiers, right? They are only available under the general purpose, not for the business critical or hyperscale. Just remember that. So under the provision, the main difference is like if you are having an application where some or the other time your users are connecting to the database, in that case, you have the unpredictable workload where you can choose the provision because you don't know when the users are going to connect. They are connecting all the time. So you choose the provision and you choose the resources, the number of vcores you would like to use. And no matter if you use like if you use the once you choose the provision, right, if you use it or not, you are going to be paid for that maximum number of vcores you choose. But that's not the case for the serverless. Like for example, if you have an application, say a timesheet application where all the users are connecting only on the Fridays till Monday morning, in that case, you do not want to waste money on the resources for the rest of the days. In that case, you can go ahead and pause your database, right? You can go ahead and pause your database so that you will be only charged for the storage and not for the CPU or memory, where you can save lot of data, especially for the demos. I use the databases to play and place them in serverless. In the real time, it saves lot of money if you know when to predict the workload. And how to create this Azure SQL database. Let's go ahead and very quickly look into the Azure portal. It's very easy. You do not need to know the code to go ahead and create your Azure SQL database. On the Azure portal, right? Once you log into the portal, go ahead and search for Azure SQL. Hit on click, and next go ahead and click on create. Once you click on create, you get all of these deployment options that we have chosen from, right? That we have talked about, sorry. So SQL database, SQL managed instance, SQL virtual machines. So we wanted to create our first Azure SQL database. So let's go ahead and click on create. Click on create. And then here there are many tabs that you have to go ahead and choose from. So let's go ahead and look into each of the tabs separately. So on the basics, you'll go ahead and choose the subscription, give the resource name, resource group name. If you do not have one, you can go ahead and click on new and just give it a name of for the resource group. So any resource that you create on the Azure, right, you need to place that resource under a resource group. You can create multiple resource group, but any resource, they have to be under certain resource group that you want. So click on OK and then provide the database name. You need to follow some of the rules to create. So create the database name. And then even though you are creating the Azure SQL database, all you get is a database, but there should be a way for us to connect to the database, right? By using Studio, Azure Data Studio, or by using Management Studio. You need to have like a server looking to connect to the server, to connect to the database. So we need to create a logical server. Click new, create new, give the server name, the logical server name, and then provide the password, confirm the password, and then the location. Location is really important to choose. Choose the location where you are from because that might depend upon the latencies and how fast your queries are running. So it is always better to choose the location you are from. Click on OK and then go ahead and choose the compute and storage. I would like to go ahead and see what all options we have. Click on configure database where you go ahead and see the service tiers and the compute tiers that we have discussed. click on the service tier to go ahead and choose. As I said, we we have this general purpose, business critical, and hyperscale, the vCore model, and the DTU model. So I would like to choose the general purpose, which is lowest cost ones. So I choose general purpose. And do you remember under the general purpose, we have two compute tiers, provision and serverless. We do not have for the other tiers, remember? So I would like to go ahead and choose provision for now. And then you can go ahead and choose the hardware configuration. I would like to choose, go ahead and see what all options we have. So change configuration to see. Here you have all of the hardware configuration. So as we go up, right, the price increase, if you see, the DC series and M series are for the hyperscale, especially. And I would like to choose the lowest cost, Gen 5. Click OK. And go ahead and scale up your vCores or scale down to see how much it might cost. Right side of the screen where it shows the estimated cost per month. And then the database size, right? You can go ahead and scale up or scale down. Your compute and the storage are completely separate if you see. And then would you like to make the database zone redundant? No, I do not want to. So I pressed on no and click on apply. And then go ahead and see the backup strategies. So we have three strategies here, three storage redundancies. Locally redundant backup, meaning your backup copies will be stored locally on the primary location. Zone redundant backup, meaning I am from Kentucky. So if I create a database at my location, the backups are not only stored at my location, but at different zones within the Kentucky. So it's like that. Geo-redundant meaning it stores the database copies not only on the primary, but geographically throughout the world, it stores the copies. Um, Asynchronously, it will go ahead and store the backup copies. So I'll choose locally redundant. Go ahead and choose on network connectivity. I would like to put public endpoint for now. Private endpoint is the most secure ones where it will disconnect all the internet connectivity and only connect to the database by using the private endpoint, private link. Now, go ahead and choose the firewalls. So here I would like to add my current IP address because I would like to show how I can connect to the Azure SQL database from my local computer. So I would like to add my current IP address. I hit yes. And then I would like to choose the connection policy. I put it as default and the encrypted connections as a default. Go to the security. This particular Azure Defender is new, where it will go ahead and assess any vulnerabilities or any threat detection, and it will send you an alert for that. But it is not a free service. You need to pay for this $15 per server per month. So right now I do not want to choose this. Go to the additional settings where you go ahead and choose how do you want your database to be created. So I just wanted to create an empty database. So I put on none. If you want to get that from the backup, go ahead and choose the backup or from the sample. It will go ahead and automatically create a sample database for you. But here I wanted to choose a none and then go ahead and choose the collation. Here is the right time for you to go ahead and choose a different collation because this is the default collation that I am showing here. If you wanted to change, this is the right time. If you wanted to do it later, it is not possible. Maintenance window, right? I would like to put it as a default. So where it will go ahead and automatically do the maintenance for you because Azure SQL Server, Azure SQL database is versionless. So it do its upgrades from the Microsoft itself. We are not going to um, uh, worry about that. So it does everything in that particular maintenance window. Now go ahead and choose the tags. Tags are nothing but like if you go to the shopping mall, right? If you look into a shirt or a dress, you have those tags with the number of dollars or number of money, how much it costs, mention on it. In the same way, you can go ahead and tag these resources that you create so that while you see how much it costs, it will be easy for you to have these tags to look into. Now go ahead and review and create. Click on create. It will take a minute to create if not minute, couple of seconds. So deployment in progress, and it will go ahead and create the logical server and then the Azure SQL database. Once it is done, it shows your deployment is complete. So you need to go to the resource to look into it. So this is my Azure SQL database that have been created. And also you will get that logical server details right side your screen, the server name, where you can go ahead and copy to clipboard and open up your local management studio. Do you remember we added our local IP address so that we will be able to connect? So paste your server and then choose the SQL Server authentication. Give the admin login ID and password that you created when creating the logical server. Click on connect, where you can see the logical server and your database. If you observe, it just look like a SQL Server instance, but you will not have the SQL Server agent or the other database mail properties here. So I would like to go ahead and quickly create a table here by using like three columns with three records. Uh, sorry, two columns, three records. So I created and I selected the database where I get my results back. So if you have the low latencies, right? If you have like it is taking couple of minutes, like couple of seconds more, and if you do not see much performance, you can go ahead and scale up and scale down the resources and see based upon your workload. I would like to thank all of our sponsors one more time for giving me this wonderful opportunity and for sponsoring for this wonderful event. Thank you so much for giving this opportunity, and thank you for moderating my session. These are all the communities from Azure Community Conference. And then if you have any question and answers, please feel free to ask me. Please provide the feedback, and thank you so much.
Hi, hi, Diti. We have one question. If we need a CDC in Azure SQL, is there any option for that?
Sorry, can you repeat that again?
Um, if we need CDC in Azure SQL, is there any option for that?
Yeah, yeah, definitely. Oh, I believe I did not add that slide here, but let me tell you this. If you type in Google that virtual training days, Microsoft virtual training days, um, you will have that series of Azure certifications where Microsoft provide the training for free for the entire year. Now for the entire year, you can go ahead and choose when you want to attend those trainings for completely free, and by the time you complete the training, they will give you a coupon code where you can go ahead and take the certifications for free, so which is really cool. And if you go to the youtube and choose Azure SQL Fundamentals, you will get a series of videos by Microsoft, Bob Ward and Anna Hoffman. There are like about like 6 to 7 videos, and each video is around one hour to 1.5 hour. And by the time you complete all of those series of videos, you can take DP 300 exam as well. So just take the one step at a time. Just start from basics. Take your AZ 900 by going to the Microsoft virtual training days. Take your certification for free, and then start your journey from there. All the resources are out there for free. You have Microsoft Docs where you get the modules. You can go ahead and read and learn from each module, and also have the video associated with that module on YouTube from Microsoft again. As I told you, by Bob Ward and Anna Hoffman, you can go ahead and read as well as learn by viewing at the same time and take your certifications. I hope I answered the
Uh,
question.
Thanks, Deepthi. We don't have any other
Thank
questions.
you.
Thanks for
And
the session.
I hope I'm, thank you. Thank you so much. I hope I did not run into the other presenters' time.
Not
Did I run into other?
no. You are on time.
Okay. Thank you. Thank,
Uh,
thank you
Thanks.
so much. Bye bye.
Bye.
Thank you.
Okay. We would like to thank all of our attendees, speakers, and volunteers who joined us today. You are an important part of the conference, and we sincerely appreciate your attendance on day one. We hope you learned something new, had fun, and can't wait to see you all back tomorrow for a session on day 2. Until then, bye from our AC Conf team. Please do watch our closing session in track 1, closing note.